Night settles over the observatories like a velvet lid, and the planet listens. Between atoms of silence, the sky breathes, a slow tide that has been rising since the first light crept across hydrogen and made a promise to time. Far beyond the last mapped comets, beneath the long shadows of the heliosphere, something pale and patient has been moving for ages. It is small enough to be missed by a careless glance, bright enough to alert those who have trained their lives on darkness. It enters the quiet like a pin drawn across glass. It is given a human shape only by a name, 3TI/Atlas, a thin thread of numbers and letters that tries to hold a visitor which refuses every net but gravity's T. The air at high altitude is brittle and clean. Domes crack open. Sensors cool themselves toward the cold of the void. Silicon waits for photons with the patient appetite of a desert. On screens, the star field appears as a familiar snow, a million white grains that do not move. Then, almost shyly, a single fleck slips. One frame, another again, and the fleck keeps stepping where the constellations do not. A machine notices first. Software subtracts yesterday from today and circles the survivor of subtraction with a digital ring. People lean closer. They find the motion modest, yet true. This is how a pilgrimage begins in the 21st century. Not with a trumpet, but with a difference image and a heartbeat that forgets its training. It carries the look of a comet, perhaps, or the pose of one. Sunlight slides over frosted minerals and wakes a breath that shines. A tale sketches a sentence that no one fully reads. The coma is a whisper, a luminous shawl that hides the core. On the blackboard of the inner system, the path chalked by that whisper tells a story about belonging, or about refusal. A curve that never closes, an eccentricity that does not drift toward unity, a speed that keeps a secret even while the sun squeezes. The signature is not a loop, not a family reunion, but a crossing. The visitor has come from a place that has no address in any catalogue printed on Earth. The human mind reaches for meanings the way roots reach for water. It looks up at the stranger and thinks of messages, or of omens, or of riddles that are their own reward. Ancient fires once polished such arrivals into gods and myths. Modern circuits surround them with numbers. Both crafts feel the same undertow. In the collective imagination, the object acquires a voice that no instrument can hear. It seems to say that distance is not a wall, that time is not a prison, that loneliness is an art practiced by stones and ice. It seems to say that the gulf between stars is full of travellers who do not need welcome to cross a threshold. Physics keeps its own poetry, one written with forces and conserved quantities. Space curves around mass, and motion writes a line nothing else can forge. The newcomer glides on that law with indifferent grace. Its energy relative to the sun is positive. Its future is not bound to any warmth we can offer. Perihelion will be a touch, not a handshake. The light will rise, the light will fall, and it will be gone. That is the ballet taught by general principles and proved by countless lesser visitors. Yet here, at this scale of strangeness, the familiar grammar sounds like a new language. The audience sits a little straighter. The orchestra of telescopes tunes to a higher pitch. There is a name stamped into the record, and the name becomes a lens. 3 I speaks of, rank and kind. A third bead on a short thread of arrivals from outside. Atlas points to the watchman, a survey that stares at the entire sky, and counts movement as if counting breaths. The designation feels spare and functional, yet it carries a hint of storm in the syllables. It carries the burden of a globe that has climbed to rooftops and mountaintops to ask the dark for a story. The label is not the thing. Still, a label can be a raft for meaning. People hold it and imagine a map suspended by strong hands. They imagine a being who holds up a world but also keeps an ear open to the wind. In the long dusk of Earth's nights, another kind of light leaves our shore. Radio murmurs outward in patient concentric shells. Radar pings bounce from planets and drift away to nowhere. Pulsed lasers test the fabric between stations in near space. Each emission is a confession of curiosity, Each is a marker of a species that has learned to throw its questions farther than its hands can reach. None of this can steer a stone or tug a snowball. Yet the thought arrives with a private thrill. Perhaps attention itself is a gravity made of intention. Perhaps the act of watching thickens the air in which coincidences flutter. Perhaps the world summons by expecting, and the void replies in its own difficult tongue. The arrival seems unscripted, and yet uncannily on cue. Telescopes have become faster and wider. Pipelines are smarter. The patient architectures of surveys that never sleep have raised the odds that a stranger will be seen while still far and faint. It is tempting to call this the work of fate. In truth, it is the arithmetic of vigilance. Millions of subtractions, billions of pixels, a calculus of persistence. Technology has given the eye a new kind of size. With that size comes a tendency towards stories that fold discovery back into desire. The line between cause and readiness blurs. Readiness feels like cause, and cause feels like a romance told in the only language the cosmos speaks clearly, which is motion. The sky keeps its distance even while it sends emissaries. The object's surface reflects a history that is not ours. Micrometeorites have scraped it. Cosmic rays have etched it. Long winters in interstellar night have sealed pores and painted varnishes that change how heat moves within. Every photon we catch is a postcard from that museum of scarring. We lift the image to the light. We tilt it. We find texture that teases more than it tells. To see is to want more. To want more is to invent new ways to see. Instruments swivel. Observers share coordinates across oceans. The planet becomes a single listening animal, turning its many eyes to a single fleck that continues to slip. Names give courage, not control. 3I/Atlas will not acknowledge our syllables. It will not slow for ceremony. It cares nothing for the timing of cultural hunger, yet the alignment feels intimate. At the edge of a century that has tasted disappointment and astonishment in equal measure, a new outsider writes its brief inscription across the sunlit hours of our system. It engraves nothing on stone. It carves nothing in ice that we can touch. The engraving happens in the mind. It whispers a question that no mathematics can cancel. Could the call of curiosity, repeated for generations, have tuned the human ear so finely that when the cosmos clears its throat, we hear it and think it was answering us all along? The observatories hum. Data flows like a broad river lit by moonlight. In that flow, a tiny island keeps its shape. It is the traveller that does not circle back. It is the reminder that space, for all its vastness, is not empty of surprise. It is a coin tossed into a fountain that runs all the way to the stars. Whether that coin landed here because a hand wished it, or because fountains are made to catch coins, is a distinction that matters only until the next glint appears. What matters, in this moment, is the hush before an intake of breath. A world holds still, counts a few frames, and sees a fleck that keeps stepping where the constellations do not. The watch begins long before night. Domes rotate through rehearsal, lenses are polished of day's dust, and the cooling systems pull the cameras toward the ambient cold of space. This is the architecture of vigilance. It is built to miss as little as possible, to convert darkness into arithmetic. The network called Atlas carries a clear purpose inside its name. It patrols with small, fast eyes that trade size for sweep, surveying wide fields again and again until motion reveals itself as a small truth among countless still points. The design is humble and relentless. Rather than stare deeply at one glittering place, it skims the entire sky many times, seeking the subtle mark of an object that will not hold still. On the ground, the stations are separated by oceans and hemispheres. One rests above Pacific lava, tasting air that has crossed nothing but water. Others look out from southern hills, where winds scrape across dry plateaus. Each carries a matched camera and a personality defined by weather and latitude. Night after night, they perform the cadence that was written for them. They tile the sky, pause, and repeat. They dither slightly to reject imposters. They shoot in filters that catch faint ice as readily as dark stone. They do not yearn, and yet their design is a physical form of curiosity. They were built to learn if something is coming. As exposures accumulate, software wakes with equal discipline. It starts with subtraction. Yesterday is removed from today. Stable stars cancel one another, leaving a residue of change. Spurious artifacts parade through as they always do. Hot pixels masquerade as visitors. Cosmic rays scratch bright wounds across individual frames. Airplanes and satellites scrawl lines that resemble intention. The pipeline has seen all of them before. It scores each candidate for strangeness and for plausibility. A learned filter throws out the noise, keeps what behaves like a moving object, and begins to link small points into short tracks. If a series of detections aligns with a sensible sky motion and fits a clock, a proposal is made. The proposal is called a tracklet. The tracklet earns a corridor through the rest of the system. Humans arrive next, not to replace the machines, but to bless and question them. A night shift astronomer scans a list of candidates, each annotated with scores and flags. A thumbnail shows a crisp starfield with a faint speck that shifts its position in a sane line across 4 frames. Another thumbnail shows a streak, too fast for a near object, too glib for a cosmic ray. Field by field, the list is thinned. One object behaves in a way that pricks attention. Its apparent motion on the sky is high, but not in the way of a satellite passing directly over the dome. Its brightness remains steady within the expected noise. The point spread looks star-like, not a smear born of a faulty track. It survives triage. Coordinates are dispatched in the language the community understands. The candidate is posted for confirmation, and the global relay begins. Robotic telescopes open where morning still sleeps. Amateur observatories pivot their tubes, joining in the old democratic chorus that has always followed a promising dot. Within hours, the object is recovered at distances that stretch the measurements into a useful arc. Timing stamps are precise. Positions are tied to catalogues refined by decades of careful work, and the residuals are small enough to make the orbit solvers smile. The sky has surrendered enough information to be fit by equations. The first orbits are always provisional, yet they tell their rough story almost at once. A hyperbolic solution appears. The eccentricity nudges above 1 and stays there as more astrometry arrives. The inbound speed at a distance far from the Sun is not compatible with a bound comet plunging from the deep freeze at the edge of the system. It looks like an interstellar trajectory. The fit is tested against the gravitational signatures of the planets and the Sunday. Solar radiation pressure is considered and found too small for the measured size. The software explores whether a slight tailwind from outgassing could counterfeit a hyperbola. The numbers resist such excuses. Gravity and geometry are sufficient to explain the path. The verdict is written in the signs of the conic sections that every student learns and very few get to apply to a true outsider. Images reveal a tiny, luminous haze around the point, a perfume of dust that means sublimation has begun. That whisper of activity is important. It gives the community confidence that the accelerations measured are not dominated by exotic forces. It also says something about material. Frozen volatiles are waking and carrying grains into the sunlight. Colors suggest dust warmed by a young day. Photometry shivers as rotating facets expose and conceal patches of brightness. The phase angle climbs, and the brightness follows in a way that maps to grain sizes and scattering laws. The newcomer behaves like a comet in some respects, but its wider context refuses membership in any local family. A designation arrives, tidy and transformative. The prefix marks it as the third recognized voyager from beyond the Sun's jurisdiction. The suffix records the survey that first raised the alarm. A name has weight in a ledger where most objects are numbers. It turns a tentative thing into a participant in history. The act is procedural and poetic in equal measure. It is also a signal to every instrument that can swing toward the coordinates. Radios tune, spectrographs prepare. Polarimeters calibrate against standard stars. The choreography is automatic because the need to measure an unfamiliar traveler is understood on every continent that keeps telescopes. The staff inside the survey buildings allow themselves a small, private stillness. They do not own the sky, but they have been its first witnesses for this event. Years of planning lie behind their minutes of triumph. Choices about mirror diameters and pixel scales were made to favor speed. The telescopes do not fear clouds because clones in other lands will cover their lapses. The alert broker that sifts candidates was taught on millions of boredom-filled frames so that a handful like this could reach the finish line. Even the network cables and the data center fans have a place in the story, because discovery in this era is a communal act of machines, programs, and people, none effective without the others. The rest of the world finds out through a phenomenon that belongs to this century. Numbers ripple through channels where professionals and devoted citizens mingle without hierarchy. Coordinates are replotted by tools that anyone can download. Exposure times are negotiated in chat windows while domes are still moving. The first stack of follow-up images appears minutes later, annotated with circles and arrows that only partially conceal the ore behind them. Reports summarize each measurement with the dry precision of the trade, while subtexts confess a species-wide fascination with origin stories. Every line of clean astrometry is a syllable in a language shared across languages. In the background, the math is classical, which gives comfort. Newton's gravitational law still handles the heavy lifting. Least squares still minimizes the differences between where an object was and where a model says it should have been. Gauss would recognize the way three observations concede a temporary orbit that later grows into a high-fidelity trajectory once more data is grafted on. Relativity lurks as a tiny correction near the Sun, acknowledged and then allowed to sleep because the path and the distances make its influence modest. The equations do not tire. They simply absorb each new dot and hand back slightly sharper predictions for where to point next. Photons carry chemistry, and so spectra are obtained as soon as possible. Even low-resolution data can sort ordinary ices from something stranger. The faint emission bands that rise from common molecules act like road signs for anyone who has learned to read them. The signal is weak at first, but it is there. Lines lean out of the continuum, revealing volatiles that every comet in the inner system can recognize. If there is anything exotic, it will take time, signal, and care to prove. For the moment, the object declares itself to be a traveler that knows how ice behaves when sunlight presses. The act of discovery ends not when the name is awarded, but when the procedures have stabilized into routine. Orbits are updated on a schedule. Observers hand off from west to east as Earth spins. Light curves are stitched. Teams specializing in dust dynamics and jet modeling begin to ask for more precise data. Planning notes accumulate for radar attempts, if geometry allows, for infrared measurements when the angle improves, for ultraviolet runs when the moon steps aside. The rhythm that follows a detection like this becomes a global heartbeat, regular and intent. All of it begins with eyes that refuse to blink. Hardware kept cool, optics kept clean, algorithms kept honest by the skepticism of those who operate them. The discovery is a harvest of patience. It is what results when watchfulness becomes an ecosystem. The timeline can be compressed into a paragraph, but the preparation cannot. Arrays were built because impacts are real, because near misses teach, and because the only way to be ready is to look early and often. A third interstellar object is not what the designers placed on their grant forms as a performance metric, yet their strategy was precisely what such a visitor required. Not luck, systematic attention. A choreography practiced until the unexpected could be welcomed without panic. At the end of the discovery phase, a portrait exists that did not exist before. It shows a moving point wrapped in a faint veil, a path across the starry background that does not bend towards staying, and a set of numbers that make a promise about where the object will be tomorrow. That is the shape of a beginning. The technology has done its work. The world now knows where to aim, how fast to expect change, and what early clues the light is willing to give away. The rest is patience, skill, and the willingness to let a new presence change how a familiar sky is read. A string of letters and numbers arrives first, crisp as frost. It fits neatly in a ledger where everything is counted and classified. It speaks of year, sequence, and a taxonomy that keeps chaos at arm's length. Then a second act follows, and the syllables change. The cold designation is dressed in a name that the mouth can carry. The transition is small on paper and enormous in consequence. With it, an object becomes a presence, data becomes a character, curiosity finds a perch, and from that height, intention can take flight. The grammar of naming is itself a map of how minds arrange the sky. Local comets are marked by prefixes that hint at activity or at the circumstances of discovery. Asteroids receive alphanumeric tags that later yield to proper names once their paths are secure. Interstellar visitors bear the letter that tells of origins elsewhere, a flag planted in the thin soil of moving light. The slash folds in a discoverer, a survey, or a watchtower built by patient engineers. The result is an anchor that ships can see. Atlas is a name that carries two lives at once. One belongs to a modern network with small mirrors, broad fields, and an appetite for repetition. The other belongs to an old imagination that pictured a figure holding up the sky. The overlap is almost too apt. A survey that lifts the burden of vigilance from human eyes shares its title with a myth that imagined shoulders strong enough to carry the heavens. When a new traveller is stamped with that label, it inherits both the dryness of a catalogue and the warmth of a story. Numbers persuade instruments to obey. Names persuade minds to care. The first effect of a name is organisational. Files must be created, priorities set, and observation queues rearranged. The moment a memorable title exists, conversations snap into focus. Proposals circulate that cite a target with a single, compact phrase. Schedulers can weigh it against weather, moon phase, and instrument readiness without mistaking it for anything else. The name becomes a rallying point for coordination across continents, a token that simplifies the many handoffs required to follow an object rushing through geometries that change by the hour. With each utterance, a plan tightens. The second effect is cultural. A headline breathes easier when it can replace code with cadence. Teachers can write the word on a board and watch it migrate into notebooks and curiosity. Artists can sketch letters that suggest shoulders and horizon. Children can whisper it to each other under blankets, tasting the feeling that the sky is speaking in a voice they can learn. Stories do not need to be untrue to be stories. They simply need a doorway through which the reader can step. The doorway here is a title that fuses watchfulness with myth. Naming also sets expectation, and expectation shapes inquiry. A title that evokes burden and steadiness suggests endurance rather than fragility, patient support rather than erratic flame. Observers may unconsciously listen for that tone in the light. They may look for rhythms that match the metaphor. They may find them because rotating ice and dust produce genuine patterns. They may temper excitement when variability refuses to behave like a fireworks display. None of this changes the photons. All of it changes the questions that are asked first, and the order in which tools are deployed. There is precedent for the power of syllables. A messenger's name given to the first interstellar visitor encouraged a reading of intent in the geometry of a flyby. A surname attached to the second emphasized the human scale of discovery, a reminder that wide skies still yield treasures to individual patience. A survey's name on a third declares the era. This is a time when machines keep the long vigil and humans arrive to interpret. The catalogue becomes both mirror and muse. Each title leaves a trace on the imagination, and the imagination returns the favour by adding contour to the questions science asks. The ceremony surrounding the christening has a quiet dignity. A committee agrees on the format, a notice is posted, and the title enters the bloodstream of databases used by every observatory that cares about moving targets. At first, the change is invisible to those not watching closely. Then the word finds its way into the small human rituals that cluster around measurement. It appears on whiteboards next to exposure plans. It appears on sticky notes beside terminals where pipeline logs scroll at a steady pace. It appears in the subject lines of emails that begin with numbers and end with an invitation to stay up late. Language widens the circle of participation. Many who will never read a spectral line can still hold a name and lean into its gravity. That leaning has consequences. It can support funding decisions. It can motivate late nights for teams already overcommitted. It can attract the attention of observatories that might otherwise sit out a faint target this season. The sky does not adjust itself to popularity, yet the quality of the portrait drawn of a given visitor certainly does. Clarity is earned by time on instrument. Time on instrument is earned by the momentum of attention. A name is a lever for that momentum. There is a subtler layer beneath the public-facing syllables. The code within software must also be named. Directories in data centers, version tags for reduction scripts, and configuration files for dynamic scheduling pick up identifiers that will live as long as archives do. Generations from now, when someone reprocesses images with methods not yet invented, the lineage will be traceable because a naming scheme made it possible. The title on the news and the shorthand in a database cooperate to write the memory that future scholars will inherit. The ocean is a useful metaphor for what a name does. Sailors give names to currents and winds, not to tame them, but to survive them. Once labelled, a phenomenon can be taught, navigated, and predicted. The same holds for an object arriving from interstellar night. Its proper title marks a fixed point in the discourse, a buoy around which instruments can circle. Currents of speculation begin to flow, but they flow around something stable. The stability is linguistic. It holds firm while theories twist and update. Myth contributes more than ornament. The figure behind the title holds up the sky, but in the ancient telling he is also bound to his task. The burden is both honour and sentence. That duality resonates with the labour of observation. Watchfulness ennobles and confines. It elevates by granting purpose, and narrows by requiring discipline. When a traveller is named for such a symbol, it invites a reflection on the ethics of attention. To look is to choose. To choose is to give up other lookings. The name embodies that choice and makes it feel less like drudgery and more like a vow. In laboratories far from telescopes, the same word echoes in contexts that do not involve optics. Teams sketch mission concepts on white paper and write the title at the top as if it were the heading of a chapter in a book not yet written. The letters frame diagrams of propulsion, communications, and dust collection. The title injects urgency into columns of trade studies where mass budgets argue with launch windows. Even if the spacecraft never leaves the page, the act of writing the name above its blueprint trains a generation to think concretely about encounters that last only days, yet repay decades of preparation. There is an economy to naming that goes beyond romance. Search queries become efficient. Data sets are locatable without ambiguity. Cross-references between radio, infrared, optical, and ultraviolet campaigns can be made without fear of synonym confusion. The speed at which understanding accumulates increases, not because the universe accelerated, but because the friction within collaboration has been reduced. In a field where opportunities slip away with the changing angle of sunlight, shaving minutes from confusion matters. A title is also a promise to remember. Many comets arrive and recede without settling into the language of general memory. Their ledger entries remain safe and quiet in the deep stacks. A visitor from beyond the sun's influence that carries a resonant name will not be shelved so quickly. It will return in lectures, in footnotes, in retrospectives, and in the gentle preface to conversations that begin with the question of what else might be passing even now, faint as a thought at the edge of sleep. Memory is the long tail of naming, and it shapes how future arrivals are greeted. In the end, a name is a compass and a mirror. It points toward a moving point in the sky and reflects the culture that chose it. The letters contain no magic that can alter trajectories. Yet they alter the landscape through which attention travels. Priorities coalesce. Instruments whisper to one another across mountains and seas. A planetary community looks up and speaks a single word, and in speaking it learns to shape 1,000 separate efforts into a single gaze. The object remains what it is. The community becomes what the name invites it to be. Gravity writes in curves carved from a single family of possibilities. A mass can move in a circle if perfectly tuned, in an ellipse if slightly free, in a parabola if balanced on the knife edge of escape, and in a hyperbola if it has more energy than the sun can hold. The path under consideration belongs to the last of these. It is a line that bends around the fire and never closes, a visiting gesture instead of a bond. The signature appears first as a set of numbers that define shape and tilt. Eccentricity rises above 1 with room to spare. Specific orbital energy remains positive, whether measured far out or near in. The verdict does not depend on a single noisy night. It persists as measurements accumulate. A hyperbola has 2 straight destinies hidden inside it. One shows where the traveller came from if the sun did not exist. The other shows where it will go if left unmolested after the bend. These are the inbound and outbound asymptotes, arrows that point to infinity in opposite directions. The sun interposes itself, curves the path, and yet cannot spend enough gravity to change the balance from free to bound. Distance compresses and then expands. Velocity climbs and then returns to nearly the same surplus it brought from interstellar night. This is what positive energy means in practice. The visitor crosses a valley, not a well. The plane of motion slices the ecliptic at an angle that refuses domestication. Local families of comets and asteroids often reveal shared tilts, echoes of formation planes, and long resonant shepherding. This orbit tilts as it pleases. Inclination is simply a number, yet here the number declares independence from the disk where planets keep their orderly lanes. A dark geometry unfolds in 3 dimensions. The path threads between worlds in a way that needs no recent planetary kick to explain its speed. No close encounter with Jupiter or Neptune can be reconstructed to account for its state. The energy is already surplus before any planet comes near. Interpreting motion inside the sun's domain requires careful bookkeeping. Heliocentric elements are useful for guiding telescopes. Barycentric elements are better for deciding citizenship. The latter measure the orbit with respect to the center of mass of the entire planetary system, removing small tugs that would otherwise mimic drama. In that more honest frame, eccentricity remains decisively larger than 1. Hyperbolic excess speed refuses to shrink into the noise. Monte Carlo swarms of clone orbits, each jittered within the uncertainties of astrometry, cluster around the same conclusion. Whether the object is allowed to approach from slightly different angles or with slightly altered distances, its energy stays on the side of exile. The Tisserand parameter with respect to Jupiter offers another diagnostic. For local comets, it tends to fall within ranges that define families. Here, the concept loses its grip. The number does not sit where Jupiter family comets sit, nor where long-period comets usually wander. The formula remains valid, but its classification power dissolves when confronted with a trajectory that never belonged to the sun in the first place. The result is a kind of dynamic silence. It says not this clan and not that one, but rather none of the above. Gravitational focusing plays a quiet role in appearance. The sun's pull bends the approach and concentrates the stream of possible paths towards smaller perihelion distances than a straight line would grant. That focusing does not change the fundamental arithmetic of energy. It does tighten the passage and brighten the days of closest approach. The same property that makes the orbit unbound also makes the encounter brief. The time spent within reach of the best instruments is measured in a span that astronomers count by lunations rather than by years. From the perspective of those who watch, the geometry is both a gift and a demand. It grants proximity and denies leisure. Capture is a dream easily described and rarely achieved. To bind a body that arrives with positive energy, something must extract that energy. A grazing encounter with a giant planet can do it, but the aim has to be superb and the geometry cooperative. A powerful jet of outgassing could contribute a braking impulse, but sublimation typically pushes rather than pulls. and its strength is small compared to the surplus carried from interstellar space. Collisions are too improbable to consider on the timescale of a single passage, so the calculus yields a practical certainty. The object will not join the inventory of long-term residents. It will leave with almost the same laughter in its speed that it brought. The vector of approach carries clues about origins even when pinpointing a birth cluster remains beyond reach. Motion is measured against the background of the Sun's own drift around the galaxy. Subtract that solar motion, and an interstellar traveller's path can be compared to the slow currents of nearby stellar neighborhoods. The alignment may hint at a chance meeting with one of those currents, or ignore them entirely. Either way, the essential conclusion stands. The object did not climb out of the Oort cloud with a barely hyperbolic twitch induced by a recent planetary nudge. It arrived with a clean surplus that does not care about our slow local eddies. Astrometry feeds and refines all of this. Each new position measurement tightens the corridor along which prediction flows. Short uncertainties in angle translate into long uncertainties in distance when projected forward. So the trick is to observe often during the time when motion is most rapidly changing. Near perihelion, proper motion on the sky can grow so large that telescopes must track at non-stellar rates to avoid trailing. Even then, the point may try to outrun exposure times. Observers manage this by shortening integrations and stacking many frames. The path that refuses home also refuses to hold still for photographs. Non-gravitational accelerations are a standard concern whenever ice wakes and vents. Gas carries dust, and dust reflects, and the whole ensemble can tug the nucleus in small, persistent ways. Modelers fit these effects with parameters that describe thrust roughly aligned with the sunline and with the spin axis. Applied blindly, such terms can counterfeit changes in orbital energy. Applied carefully, they reveal themselves to be minor players compared to the Sun's command. In the case under discussion, the measured accelerations never approach the magnitude required to push a bound object into a convincing hyperbola. They add texture without rewriting fate. Conic sections have a way of embodying philosophy. An ellipse is a promise kept. A parabola is a farewell whispered at the exact threshold. A hyperbola is a greeting that contains goodbye in the same breath. Watching the curve unfurl across coordinate grids and star fields is to watch inevitability rendered with elegance. Predictions for tomorrow's position stretch into forecasts for next month and beyond, all resting on a handful of constants and a few immaculate laws. The mind learns to see the entire route at once. Inbound eternity collapses into a few weeks of brightening. Outbound eternity begins before the echo of arrival has faded from instruments designed to linger. There is also the matter of where the track crosses, things we care about. Planetary orbits intersect the plane of the ecliptic like chalk rings on a blackboard. This intruder's plane slices those rings on a slant, skimming some, missing others by comfortable margins. Risk is assessed and quickly put to rest. The visitor offers spectacle, not danger. It threads the inner system as a needle intent on its own cloth, paying little attention to where humans have placed their concerns. Leaving requires almost no effort from the traveller. The sun does the bending. The same gravity that fails to capture still draws out a long accent in the music of motion. After perihelion, the velocity vector tilts outbound, regains the asymptotic direction with a slight rotation, and settles into a speed that is the mirror of the inbound surplus. If dust and gas have complicated the light, they have not complicated the mathematics. The conic section is patient with complications. It absorbs them as small perturbations and continues to dictate the main storyline with serene authority. Charts drawn in the local frame can be reimagined on a broader canvas. Translate the path into galactic coordinates, and the figure acquires a different dignity. The sun crawls around the Milky Way on a track that takes hundreds of millions of years to complete. Against that river, the visitor's path is a short vector, a flick of a small fish through a massive current. The scale changes, but the diagnosis does not. In every frame worth choosing, the energy condition declares freedom. The refusal of home is not an act of will. It is a bookkeeping entry in the ledger of mechanics. Yet the effect on those who study the sky carries the flavor of narrative. A line crosses a known field, announces its character by the inevitability of its curve, accepts a brief interrogation from instruments that know how to listen, and then moves away without regret. What remains is not a trail of debris or a ring of captured fragments. What remains is a map of where it was and a prediction of where it will be, both contained in the same arc that defines an object immune to adoption. First light is never only light. It is a message folded into brightness, a quiet pulse that computers translate into numbers and people translate into questions. On the earliest nights of attention, the newcomer sits as a softened point, a core wrapped in its own breath. Photons arrive with the timing of a heartbeat. Magnitudes are measured, subtracted, corrected for air mass, and seeing, then placed upon the simple axis of distance from the sunday. The brightness climbs more rapidly than a naive inverse square would admit, not wildly, but with a confidence that speaks of ice waking and dust learning to scatter. Color follows close behind. Filters rotate through their sequence, green, then red, then near infrared, and the differences tell more than any single band can reveal. The slope is faintly red, not the deep brick common among the most processed bodies, not the neutral grey of bare rock. It suggests grains coated in organics but not thickly laminated with age. Polarimetric measurements add a layer of texture. The degree of linear polarization rises with phase angle in a curve that lies between familiar families. It does not match the median of long-period comets by instinct. It does not copy the signature of dust-poor bodies either. The graph hints at aggregates rather than monomers, at porous clumps that twist sunlight into a glinting fog. Spectra arrive in fragments, because the object is faint and the sky is jealous. Low resolution scans tease bands that belong to common volatiles. Cyanogen leans out of the continuum, but without its usual exuberance. The greenish whisper from diatomic carbon is present yet restrained. In the infrared, absorption by water ice is hinted at through slope changes that resist other explanations. Carbon monoxide and carbon dioxide sit at wavelengths that demand instruments in narrow windows of atmosphere or in orbit. Early numbers offer upper limits and possibilities more than declarations. Even that caution speaks loudly. There is nothing that screams of chemistry unknown to the inner planets, and yet the ratios wear an accent. Dust production can be approached by a proxy that observers have refined over decades. A number with the shorthand AF-rho is computed from coma brightness within a small aperture, a way to guess how much reflective material is being lifted into sunlight. The value lands in a region that would be ordinary for a local comet at similar distance, except that gas production inferred from line strengths appears modest. The quotient of dust to gas leans heavy toward dust. That tilt is a clue. It can be read as evidence for a crust that resists venting, a surface where interstellar weathering has sealed pores with a varnish of irradiated hydrocarbons, so dust must be dragged free by sporadic vents rather than by fountains of vapor. Morphology deepens the story. On stacked images, the coma is round, but not perfectly so. A sunward fan extends like a breath exhaled through pursed lips. The anti-solar tail carries larger grains that lag, drawn into a gentle arc by radiation pressure. When the frames are traced with synchrones and syndynes, a pattern emerges that points to a small number of active regions rather than a uniform exhalation. Rotating jets could carve the visible air into spirals, faint and slow, if the cadence of observations is right. The presence of structure encourages a search for rhythm. Photometric time series provide that rhythm. The light curve undulates by a few tenths of a magnitude on timescales of hours. The modulation is clean on some nights and muddy on others. That behavior hints at a nucleus that may be tumbling rather than spinning neatly about a single axis. Non-principal rotation is not rare among small bodies, but when coupled with outgassing, it forms a feedback loop. Jets apply torque that changes the spin state, and the changing spin state redirects the jets. The resulting choreography complicates the effort to assign a single rotation period. Modelers tried double-peaked solutions and switched to damped tumbling equations when those fail to fit. Each hypothesis carries implications for the internal coherence of the nucleus, for its elasticity, for its memory of impacts or thermal stresses long endured in the dark between stars. Thermal emission remains too faint for early clarity, yet even limits can be generous. A blackbody fit to the meager infrared flux suggests a low geometric albedo, as expected for dusty ice, and a size that lives in the realm of a few hundred meters to a kilometer if the coma contribution is properly accounted for. The truth is a range, not a point. If the dust is unusually efficient at scattering forward, the nucleus could be smaller, with the coma doing more of the work. If the dust is coarse and dark, the opposite holds. That ambiguity is familiar, yet it is sharpened by the knowledge that material properties may have been sculpted by a radiation climate alien to our own. Early attempts to measure non-gravitational acceleration proceed in parallel with orbital refinement. Positions gathered across a range of distances are fit by a force model that includes tiny thrust aligned with the Sun and modulated by heliocentric distance. The result is not dramatic. A gentle push is there, as expected for a venting surface, but it does not dominate. The implication is comforting. Gravity still carries the main burden of motion, yet the direction of the small residuals, if they persist, can betray the orientation of the spin axis and the latitudes of the most active areas. A portrait of invisible geometry begins to form, drawn with lines that are closer to inference than to depiction. In the chemistry, the most tantalizing hints lie not in exotic molecules but in scarcity. Cyanogen is weaker than in a typical local comet at the same energy input. The oxygen-bearing lines do not overperform. If carbon monoxide later declares itself strongly at larger distances, that would point to an inventory settled in colder birth zones, with gas trapped in amorphous ice that keeps secrets until warmed. If it refuses to appear in strength, then the object may be telling of a nursery where ultraviolet fields or shocks burned off the most volatile species early. Both readings remain open. Both would mark a childhood framed by rules that differ in degree or kind from those that wrote the stories of most icy wanderers that come from the outskirts of this system. The coma's texture under high-resolution imaging contributes another thread. Point spread functions sharpen under adaptive optics, and within the roundness a slight sunward cusp flickers. The feature aligns with the expected direction of solar illumination, consistent with a jet near the subsolar latitude. On later nights, that cusp tilts, a sign that the subsolar point has migrated across a sloped world, perhaps across a ridge that channels gas, perhaps across a topography carved by slow sublimation over epochs far from any star. Topography cannot be resolved, but its shadow appears in the way brightness leans and relaxes. A question rises from these modest strangenesses. Why does the ensemble feel familiar and foreign at once? The coma is a cometary coma, the tail, a cometary tail. The brightening with approach obeys a law honed by thousands of observations. Yet, the ratios hum at a different pitch. The dust hangs in a fog that seems older, or tougher, or built from aggregates that do not fragment as easily. The gas speaks a thinner dialect. The polarization curve nods to known families and then walks on. The light curve wavers as if the nucleus prefers to dance askew rather than to turn like a clock gear. No single item breaks a rule. Together, they write a personality. From the first light onward, every measurement bends into a pair of desires. One is to cradle the object inside categories, to say, it is this kind of comet with this albedo and this activity law. The other is to let it teach new categories, to enlarge the map by admitting that chemistry and grain physics bear the imprint of star-forming regions that never contributed to the solar inventory. In practice, both desires cooperate, classify enough to predict, wonder enough to stay open. The early glimmers justify both stances. They bless familiarity, then step aside to reveal a tilt that makes the ordinary feel slightly off-axis. By the time the first week of data finds its way into shared archives, the questions have sharpened. What volatile dominates as distance shrinks? How does the dust size distribution evolve with sunlight? Does the spin state drift in a way that betrays strong jets or weak ones? Do colors curve toward neutrality as fresh material is exposed, or toward deeper reds as fine grains blanket vents? Each query is a doorway into a laboratory that no human built. Sunlight is the instrument. The nucleus is the sample holder. Time is the only reagent that cannot run out. Textbooks teach a reassuring rhythm for icy bodies that wake in sunlight. Brightness should rise with distance, according to a tidy exponent. Dust and gas should increase together like partners taught the same steps. Spectra should unfurl the usual family of emissions with familiar ratios. Polarization should follow curves learned from decades of comets, dipping to a minimum at small phase angles, then climbing in a way that betrays grain sizes and porosity already catalogued. Rotation should write a near-periodic wave across the light curve, a heartbeat steady enough to solve with patience. That rhythm holds in outline, yet edges fray in the details. The newcomer obeys the score, then inserts syncopations that force the orchestra to lean forward. The rise in brightness with approach does not settle on a single slope. Instead, a knee appears, a change in tempo that arrives sooner than water ice alone would demand. Before the sun can warm a surface enough for ordinary fountains, activity grows faster than expected, as if a second instrument has joined the ensemble. Carbon dioxide or carbon monoxide can play that part. Each sublimates at lower temperatures, sending gas across the surface while water remains drowsy. If those volatiles are trapped in pockets, the ensemble will grow in bursts when sunlight reaches those caches. Later, near the days of strongest heating, the slope relaxes again, as though the early contributors have thinned and water has taken the lead with a steadier hand. A single power law cannot cradle this behavior without strain. Gas lines rise, but not with the exuberance that dust suggests. The coma glows as if lifted by a generous wind, yet the signals from classic tracers are restrained. The dust-to-gas ratio leans toward dust. Such a tilt can form if the surface carries a toughened rind, a result of long irradiation far from stars. That crust resists steady venting. Small regions still break through, dragging grains into a luminous fog, but broad fields remain sealed. The chemistry that once flowed is present, only quieter, a voice that must pass through filters of age before it can be heard. Polarimetry adds another nudge to expectation. The minimum polarization appears shifted, the curve slightly altered from averages built on local comets. This change is subtle, but it points toward grains arranged more like airy clusters than solid beads, or toward a deficit of the very smallest particles that usually deepen the dip. Either way, the light remembers a different workshop, a place where aggregation or attrition produce textures that scatter with an accent. The phase function strengthens that impression. Forward scattering surges beyond comfortable templates, drawing a shallow halo around the core when geometry aligns, as if larger, more intricate grains are tilting mirrors with unusual efficiency. The morphology of the coma refuses perfect symmetry. A sunward fan appears with a crisp edge, then softens, then sharpens again on a new bearing. The tail marks time with arcs that fit synchrones traced to discrete release times, rather than to a quiet, continuous simmer. Modelers who begin with the simplest prescriptions quickly add layers. They allow for jets that turn on with morning, pause at noon, and fade at dusk because thermal inertia lags behind illumination. They add a nucleus with slopes and basins so that local sunrise arrives earlier for one vent than for its neighbor. The result is not chaos, but it is not the clean circle of gas gently pushing dust away from a uniformly active sphere. Rotation writes a line that refuses easy music. Light curves built from long nights show modulations that migrate. Period searches find candidates, then lose them when a new week's data enters the field. A single axis spin would settle these arguments. A complex state does not. Tumbling can persist for years when torques are small and damping is slow. In such a state, the direction of the spin axis precesses, and the surface that faces the sun this hour is not the surface that faced it last night. Jets that follow their local noon deliver thrust vectors that wander. To observers, the drift masquerades as caprice. To the nucleus, it is simply the geometry of an irregular world turning in a light it has not felt for eons. Non-gravitational acceleration emerges at a level fit for comets, then points a few degrees away from the expected line. The offset is not enormous, but it persists across enough measurements to earn belief. Seasonal effects can supply the cause. A high obliquity places active zones into and out of solar favor with dramatic swings. A jet on a tilted pole can press the nucleus in a direction that is neither exactly sunward nor anti-sunward. When averaged over a rotation that is itself evolving, the vector becomes a gentle compromise. In the ledger of motion, the sun still holds the pen, yet a thin margin accumulates written by vapor. Thermal physics offers a key to the odd early knee and the later softening. Ice laid down in the cold dark can keep volatiles trapped within its amorphous structure. As temperatures climb, the matrix rearranges into a crystalline form, exhaling the gases that once slept in its pores. That transition can come in waves, racing along layers warmer than their surroundings, tapping reservoirs that remained invisible until the moment of change. The light curve records that drama as a surge that defies any straightforward heliocentric law. Later, when most of the easy pathways are exhausted, the awakening smooths, and the comet behaves more like a textbook would prefer. Grain sizes hint at an unbalanced inventory. Very fine particles that normally blue the spectrum appear modest in number. Coarser aggregates dominate, trailing into a tail that bends gracefully under radiation pressure, but carries weight close to the nucleus. Such a distribution alters color slopes, polarization, and scattering all at once. It also reshapes how outgassing couples to motion, gas drags, coarse grains, less efficiently than it lifts fluff. The coma brightens without feeding an outsized thrust, explaining a small, non-gravitational signature in the face of active dust release. Fragmentation does not dramatize the scene. No obvious carving presents itself. No sudden double source walks apart in images. Instead, micro-shedding events pass like sighs, too gentle to multiply nuclei, but strong enough to refill the dust halo after each lull. Strength must therefore be non-zero. The body holds together under changing illumination and under jets that could pry at seams. A cohesive layer inches deep may suffice. Interstellar weathering can sinter surfaces, melting edges into bridges at the scale of grains. What would crack in the young, weak crusts of fresh comets might only crumble silently here. The lack of an easy category has practical consequences. Reduction pipelines that assume spherical outflow with a constant speed must be coaxed to accommodate anisotropy. Simple Hazer recipes give way to Monte Carlo dust codes that can inject jets, rotation, and size distributions through time. Polarimetric inversions borrow new priors. Radiative transfer models include low filling factor aggregates and irregular shapes. Every parameter gains a range, and every range is wider than custom. The sky is not rebelling against physics. It is asking that physics be applied with richer texture. By the time trends speak clearly, a picture hangs in the air that is both disciplined and surprising. The object behaves like ice awakened, yet it keeps the tempo of a traveller carved by a century of cold cosmic rain. Its early activity smacks of supervolatile sponsorship, then hands the baton to water. Its coma glows with dust that seems older, tougher, or stitched into larger, airier clumps. Its rotation refuses a single tidy period. Its push against the sun is gentle and slightly askew. None of these notes alone would merit a revision of the textbook. Together they sketch a margin in the text where penciled comments grow dense. Rules do not break in this encounter. They bend where boundary conditions change. A small, irregular nucleus, with a crust shaped by ages without daylight, will not echo the behavior of a body that has looped our star many times. Grain physics taught by one nursery can differ from grain physics taught by another. Volatiles learn to hide where radiation wrote hard chemistry into the first micrometers. When those volatiles finally see dawn, they answer with fits and starts rather than with fountains that sing on schedule. The differences are not defiance. They are history speaking through heat and spin. What lingers after the measurements are filed is a recalibration of expectation. The categories built on local wanderers remain useful, but their borders require soft edges. Slopes can change mid-approach. Gas can underperform dust without implying a barren core. Polarization can whisper of architectures that grew far from the Sunday. Rotation can wobble and still hold a coherent shape. The surprise is not that an interstellar traveler stretches the template. The surprise is how gently it asks for that stretch and how clearly the request is written in its light. The faint atmosphere around the traveler is a library made of light. Photons lift off the expanding cloud, each carrying a syllable of chemistry, a hint of temperature, a memory of the forces that set the grains and gases free. The glow is not decoration. It is a coded breath, written in lines and continua, in polarization and in color, in the slow choreography of jets that sketch transient spirals and fans. Sunlight begins the story by breaking molecules into families. Parent species sublimate from vents and pores, then drift into day where ultraviolet quanta strike and split them into daughters and granddaughters. Hydroxyl blossoms from water. Cyanogen grows from hydrogen cyanide. Diatomic carbon rises from more complex precursors that unravel in stages. Each fragment has a lifetime set by heliocentric distance and solar activity. Each flies outward at a speed that reflects the gas temperature near release, faster close to the heat, gentler farther out. A shell of activity forms, collisional and warm near the core, then thins into a free molecular wind where particles rarely meet and memory of their birth fades. Spectra act as translators. In the blue and green, bands of Cn, C2, and C3 climb out of the dust continuum, each with a pattern of substructure that can be modeled to yield column densities. In the ultraviolet, broad emission from OH carries the signature of water split by the sun, a proxy for the most abundant volatile when distance permits. The visible holds a subtler clue in forbidden oxygen lines. The green auroral line near 557, 7 nanometers, and the red doublet near 630 and 636 nanometers do not speak with the same loudness when water dominates as they do when carbon dioxide contributes. Their ratios give a handle on how much carbon dioxide rides with water in the jets, a lever useful even when infrared windows are closed by atmosphere. Fluorescence makes these signals bright. Molecules do not glow by heat alone in a tenuous coma. They absorb sunlight and re-emit through cascades, a process governed by G-factors that depend on the relative motion between comet and Sunday. As the object races inward, the heliocentric velocity shifts solar lines across molecular resonances. The swings effect modulates brightness for some species, a small tremor that a careful observer can separate from true changes in abundance. By following that tremor, one can see through the Doppler mask to the inventory beneath. Band shapes carry thermometers. Rotational substructure in Cn or C2 responds to gas temperature in the inner coma. Fit the distribution and a rotational temperature appears, tends to low hundreds of Kelvin depending on activity and distance. That number is not the surface temperature, nor the sunlight itself, but the kinetic state of gas after a short run of collisions near the vents. It guides the estimate of expansion speeds and helps set the scale of the region where molecules talk to each other before they drift into silence. Dust writes the counterpoint. Continuum light, reddened by small grains and soot-like organics, outlines the scattering fog that makes the coma look fat, even when gas lines whisper. Polarization of that continuum varies with phase angle, telling of porosity, shape, and size distributions. High porosity aggregates, Clusters of submicron monomers, loosely bound like brittle snow, tilt polarization curves in recognizable ways. Coarser grains mute the color and shift the angle at which the polarization minimum appears. Measure those curves carefully, and a fractal dimension emerges, a number that whispers how gently particles glued together in the cradle that made them. Jets make the code dynamic. A vent near the local noon sprays gas and dust sunward, forming a cusp that camera stacks can isolate. As the nucleus turns, that spray becomes an arc, then a corkscrew, its pitch set by rotation rate and the outflow speed. Syndynes and synchrones, curves that assume given sizes or release times, map tails into families of strands, fit those strands, and active regions reveal their latitudes and their hours. Add polarimetry, and the same strands betray the sizes of grains they carry. The coma turns from haze to handwriting, and the handwriting can be read. Farther from the core, the solar wind takes an interest. Neutral atoms become ions under ultraviolet light, or by charge exchange, and the wind's magnetic field drapes around the cloud. Pickup ions are swept downstream, forming an ion tail that gleams in discrete species. CO+ can blaze in the violet, its bands strung like lanterns along the flow. H2O+ and N2+ can appear when the inventory allows, each a witness to formation temperatures in the original nursery. The angle between dust tail and ion tail widens or narrows with the solar wind, a visible geometry that records invisible fields. Radio and millimeter wavelengths open a colder archive. Rotational lines of carbon monoxide, hydrogen cyanide, methanol, and formaldehyde fall into windows where sensitive receivers can listen, their strength ladder with upper state energy. Plot those ladders and a rotation diagram yields an excitation temperature, a cousin to the kinetic temperature in the inner coma, but shaped by radiative processes and collisions as density thins. Ratios between lines separate optical depth effects from true abundance. If the signals are strong enough, hyperfine structure in some species can offer optical depth directly, turning models from guesses into measurements. Spin symmetries matter for some molecules. Water, ammonia, and methanol carry ortho and para forms, identical in chemistry yet different in nuclear spin alignment. Their ratio freezes at the temperature where molecules were last equilibrated in bulk. Measure that ratio, and the breath becomes a diary entry from the epoch of assembly. Warmer birth zones and colder ones write different numbers. Even when non-equilibrium processes complicate simple readings, the ratio adds a constraint that any origin story must satisfy. Isotopes speak with a softer voice but carry decisive weight. The abundance of deuterium in water, the balance of carbon-12 and carbon-13 in simple species, the proportion of nitrogen-15 in CN, all point toward conditions in a protoplanetary disk or a natal cloud. Interstellar night can blur those hints through cosmic ray processing and slow chemistry on grain surfaces, yet traces remain. With sufficient signal, even a broad constraint can rule out pedigrees, insisting that some nurseries are more likely than others. Hydrodynamics shapes the inner kilometers. When production is high, collisions knit the gas into a single fluid that accelerates away from the surface, like wind crossing a mountain pass. When production is low, molecules decouple quickly and move ballistically, a free escape where each particle keeps its own counsel. The boundary between regimes shifts with solar distance and with the health of vents. Temperatures set sound speeds, mass loading by dust steals momentum, and the entire flow can be computed from conservation of energy and mass once composition is known. The result is a set of velocities that translate photochemistry into spatial brightness profiles, a map that bridges models and images. Heat moves through the nucleus with a lag that imprints itself on the coma. Thermal inertia delays the response of buried ice to changing sunlight. A vent may peak in output after local noon and drift toward evening before sleep. Slopes and hollows alter the angle between sun and surface normal, funneling gas and shading neighbors. Even without resolving the body, these effects enter through time series. Watch the coma dance on a cadence of hours, and the hidden landscape takes a ghostly shape. Electrons born in photoionization carry extra heat into the gas. They collide with neutrals and lift vibrational states, a path to infrared emission that glows without large quantities of dust. Measure that glow with narrow filters, and the rate of energy deposition by electrons emerges. That rate feeds back into the speed of expansion and the ionization balance. The breath encodes not only what is released, but the processes that sculpt it after release. Radiation pressure sorts grains by size in flight. Micron grains sail, sub-millimeter grains lag. Millimeter grains barely move from the nucleus in the hours after they are lifted. This sorting writes gradients across the coma that are not random. Blue light grazes the edges as tiny grains dominate. Redder hues cluster near the core where larger aggregates linger. Polarization follows suit. By mapping color and polarization together, one can reconstruct the evolving size distribution as vents rise and fall. All of these threads tie into a larger inference. Ratios of water to carbon dioxide and carbon monoxide, presence or absence of nitrogen, prevalence of methanol and formaldehyde, spin symmetries, isotopic balances, grain architectures, and the vigor of electron heating each suggest birth temperatures, ultraviolet fields, and dust recipes in the natal disk. A nursery rich in carbon monoxide at tens of Kelvin will write one set of signatures. A region nearer to a young star where water dominated the ice budget will write another. The coma acts as a language that remembers those lessons even after a journey through darkness that erased most obvious scars. Decoding proceeds with patience. No single line or curve can claim the final word. A set of concordant hints, spread across wavelengths and methods, converges toward a portrait that does not need to resolve the nucleus to know its habits. The breath, properly read, says what it prefers to eat, how it holds together, and how it learned to speak when warmed after a silence that lasted longer than civilizations. The code is not designed for human eyes, yet human eyes can learn the grammar, and in that learning, a distant shoreline comes into view. The heart of the traveller sits hidden inside its own breath. A compact body walks behind a veil of dust and gas that it weaves as it warms, a tiny world wrapped in a silence made of glare. Telescopes are patient thieves. They steal clues from the light that escapes the shroud, and from the ways that light is arranged. The nucleus resists the theft by being small, dark, and encased, but patterns betray it all the same. Direct sight is rare for such a core. The coma renders a star-shaped blur that mimics a point source. To separate one from the other, images are fitted with a stellar template and a smooth envelope that falls as brightness over distance in a near hyperbolic curve. Subtract the template, and the coma remains. Subtract the coma, and a residue that behaves like a bare point may appear. Often the residue is an upper limit, a whisper rather than a statement, yet even limits in form. They insist that the reflective body is no wider than a few hundred meters, perhaps a kilometer at most, if grains near the core are especially efficient at scattering. Albedo sits low, a typical fate for icy dirt that has spent ages under radiation. Dark surfaces return little sunlight, and that scarcity pushes any inferred size higher for the same measured flux. Thermal emission should refine the estimate, since warm bodies shine in infrared colors that are less polluted by dust reflection. The coma complicates even there, scattering and emitting in its own right. Still, models tested against faint infrared glows yield diameters that favor smallness. A tiny traveler makes sense. Interstellar attrition encourages survivors built like stones in a riverbed, compact enough to withstand slow sandblasting by dust and ions between stars. Shape is the next secret. A perfect sphere would present the same cross-section to sunlight at every rotation and would draw a flat line across a light curve once the coma contribution is removed. A real nucleus rarely obliges. Even diluted by haze, the brightness rises and falls with a rhythm measured in hours. The amplitude is modest, a few tenths of a magnitude. implying a body elongated but not extreme. Perhaps a ratio of long axis to short axis near 2, perhaps less if the viewing angle never provides a true profile. Contact binaries can mimic such signals. Two lobes touching and rolling together, their silhouette changing as a soft hourglass turns in space. Without a resolved image, the distinction remains mathematical, but the math prefers irregularity over symmetry. Internal strength is inferred from what does not happen. No sudden fractures pull the light curve into discontinuity. No companion kernels walk away in high-resolution stacks. Outgassing that could tear a rubble pile apart instead produces gentle, collimated jets. Cohesion must be present. At scales of meters and tens of meters, Van der Waals bridges between grains can supply tensile strength. Ice that has flowed slowly under cycles of heating and cooling may have sintered contacts into tougher bones. A small world can hold together without much gravity if its fabric is interlaced by such microscopic ties. Density hides behind dynamics. When jets push, the nucleus responds with a drift that precision astrometry can measure. A large acceleration for a given gas production would point to a low mass. A small acceleration would suggest the opposite. The measured push is present yet modest. Within the bands of uncertainty, it allows bulk densities in the neighborhood of a few hundred kilograms per cubic meter to perhaps near 1,000, values that join porosity with ice. Pores carry memory of formation. Cavities store volatiles. Channels guide release that looks like weather. The skin remembers an even older story. Cosmic rays spall molecules into radicals that recombine into tarry films. Micrometeoroids hammer and sinter. Ultraviolet breaks bonds at the topmost layers and encourages crosslinks that reduce permeability. The result is a thin armor, perhaps centimeters deep, darker than what lies beneath, reluctant to pass gas. Cracks form when internal pressure rises, or when thermal stress accumulates along day-night boundaries. Those cracks become nozzles. They collimate jets that carve the coma into patterns. The same armor may suppress wholesale erosion, leading to higher dust-to-gas ratios as grains are dragged from the edges of fissures rather than launched in fountains. The rotation state is a diary of torques. If the nucleus were a rigid spinner, a single period would dominate, written across weeks with a clean repetition. Instead, the solutions wander slightly. This can be the signature of non-principal rotation, a tumble that evolves slowly as jets raise and lower their thrust. Damping timescales for such states grow long when bodies are small and porous. Energy stored in off-axis spin bleeds into heat at a pace measured in years or more, not days. The nucleus may therefore carry an old wobble acquired in a distant encounter or from a past episode of stronger venting. That wobble keeps active zones under shifting angles of sunlight, changing their schedule without altering the deep habit of the body. Heat does not sink far. Thermal skin depth for a period of hours reaches only a few centimeters for fluffy ice dust mixtures. Seasonal skin depth for a passage through perihelion might penetrate decimeters. Deeper than that lies a winter that never really ends. Volatiles trapped in amorphous ice wait for temperatures that will not arrive during a single flyby. They will feel only a tickle from rising warmth, enough to rearrange bonds in a slow migration toward crystalline order, enough to exhale minor reservoirs of gas that add shoulders to production curves, not enough to wake the whole interior. The nucleus is therefore a layered archive. The present acts on the rind. The past sleeps intact behind it. Topography cannot be seen directly, yet it casts shadows in the coma. Sunward cusps pivot as the subsolar point walks across a tilted shape. Repeating fans suggest highlands that meet dawn earlier than neighbours. Lulls that coincide with a particular rotation phase hint at valleys where gas stagnates until the sun climbs high. If the nucleus hosts pits, they act as natural collimators. If it hosts cliffs, they fracture under thermal strain and feed sudden puffs that ride dust into broader wastes. The portrait that emerges is not detailed, but it is textured. Peaks and hollows exist, and they matter. Electrostatic forces may help at the margins, Ultraviolet light and the solar wind charge grains differently on day and night sides. Near the terminator, where shadows creep and vanish, the electric field can lift the finest particles with a gentle flutter. That lofting alone will not build a coma, but it can prepare surfaces for gas to claim them. It can also explain rare instances of faint halos that appear even when classic gas tracers seem weak, a sheen born of grains suspended close to the source before being dragged into the main flow. The nucleus loses mass at a rate that can be integrated over the weeks around closest approach. Dust production informs one half of the tally, gas production, even when modest, informs the other. The total is small compared to the body that pays it, a shaving taken from a stone that has endured colder hazards for far longer. Over many such passages, a local comet hollows and splits. An interstellar wanderer will not return on a human timeline, so its budget is paid once, which matters for inference. The surface we watch is not shaped by repeated visits to a bright star, but by a single season of warmth laid upon an age of night. Radar would write a clean biography if geometry allowed. A hard echo would reveal size and spin in hours. Distance and speed deny that luxury in most cases, leaving the burden to optical and infrared methods. Stellar occultations offer a rarer path. When the coma slips across a background star, the star's light dims in a profile that depends on gas and dust density. If a solid body briefly blocks the star within that haze, the dip sharpens. Predictions for such alignments are difficult, and the events are brief, yet even a single successful chord can bracket dimensions in a way that lifts size estimates from guesswork to measurement. Everything learned points to a worldlet that is sturdy, small, dark, and irregular, a body with a crust that has been tempered by ages without sunrise, with vents that open where stress and heat conspire, with a spin that wobbles gently beneath the touch of its own breath. It is neither a shard of metal nor a snowball of pure frost. It is a composite, granules and ices welded by time and pressure into a sponge that holds space within itself. Pressed by sunlight, it speaks with a voice quiet in gas and rich in dust, and in that voice the shape of the speaker can be heard. The silence around this core is not emptiness. It is a pause between clues, a spacer that lets one inference settle before the next begins. By listening closely to the veil, the body within becomes less hypothetical and more real. A sketch replaces a silhouette. The sketch is not a portrait, yet it is faithful in spirit. It shows a traveller that has learned to endure, that wastes almost nothing, that keeps its memories just under the skin and offers them in grains and vapours to any listener able to read. The sun stretches a hand across space, and the traveller feels the pull. Gravity thickens the path, curving a straight intention into an elegant aside. The warmth grows, the light sharpens, and the speed climbs as though the object had agreed to a dance that lasts exactly one song. A promise of capture is not in that touch. The visitor carries surplus energy, the simple surplus of motion acquired in another neighbourhood of the galaxy. In the arithmetic that decides fates, that surplus keeps its sign. The sun can bend a course, but not close it, without an accomplice that steals energy away. Motion around a star is a book written in one clear sentence. If the speed far from the light is v infinity, the speed near any distance r obeys a square root law that adds the star's gravity to that inherited haste. The closer the approach, the larger the borrowed speed, and the more dramatic the arc. Yet the bookkeeping remains exact. What was positive stays positive, only momentarily disguised by a flourish of acceleration near the fire. When distance grows again, the extra speed sloves off, and the trajectory returns to the same quiet surplus it brought in. Gravitational focusing gives the invitation its charm. Approaches that would have missed by comfortable margins are drawn inward. The apparent cross-section for a close pass expands. A wider funnel of possibilities leads to days when cameras can drink photons at a useful rate. This focusing also tightens the bend. The deflection angle swells when the impact parameter is small and the inherited speed is modest. But here, the inherited speed is not modest. Interstellar wanderers carry tens of kilometers per second relative to the Sunday. At such pace, even a near miss becomes a quick bow. The path acknowledges the sun's authority and keeps its own counsel. Capture requires a loss. In the language of orbits, specific energy must turn from positive to negative. That change demands a braking impulse with magnitude comparable to the inherited speed. There are not many mechanisms on offer in open space. Gas drag on a solid nucleus does not exist because there is no atmosphere to lean upon. The solar corona is far too thin at astrophysically safe distances. Tidal friction can heat and twist, but cannot drain enough momentum without tearing the body apart. The sun's light pushes dust outward, not inward, and for a compact nucleus radiation pressure is negligible. Outgassing is an engine, and could in principle be turned to braking. In practice, the thrust is a whisper. Gas escapes at hundreds of meters per second from vents that are small compared to the surface. The reaction force integrated over a few weeks might change the speed by millimeters per second, perhaps centimeters per second, if activity is vigorous and well directed. The deficit to erase is measured in tens of thousands of meters per second. The gap between need and supply is not a crack. It is a canyon. Planets offer leverage because they move. An object passing near a planet can trade energy with it, enter from behind a giant like Jupiter and leave ahead, or the reverse, and the sun-centered energy can change. This is the trick behind gravity assists. It is also the only plausible road to binding an interstellar entrant. The road is narrow. The visitor must pass inside a planet's hill sphere, close enough for a strong tug, yet not so close that the geometry sends it away faster. The approach angle must be tuned so that in the planet's frame the speed is low enough for significant deflection, and in the heliocentric frame the outcome subtracts rather than adds energy. High inherited speed fights that recipe. Relative to Jupiter, a newcomer arriving with tens of kilometers per second will have only a heartbeat within the sphere where Jupiter rules. Deflection scales down as the moment shortens. The target area for just the right geometry shrinks to a thread. Temporary capture can occur in some worlds for some wanderers, a hop that loops once or twice before the sun steals the victim back. Permanent binding is an alignment of circumstances, so exacting that waiting for it is like waiting for two falling leaves to touch mid-air, while a wind shifts direction twice. Tisserand's arithmetic, a relationship that ties a small body's motion to a planet's orbit, is another quiet judge. Bound comets near a given planet tend to cluster in Tisserand values that betray their long relationship with that world. An interstellar path does not wear those values. It arrives from a background where Jupiter's shepherding was never felt. The geometry required to slip into the familiar families is not impossible, but it is not the way of things. The newcomer meets the great planet as a stranger and leaves the same. The Earth and the smaller worlds present even thinner chances. Hill spheres shrink with mass. The corridor in which a strong exchange could be arranged narrows to a hair. A capture by our own planet would require a pass within a distance, measured in a handful of Earth radii, and a relative speed small enough to allow Earth's gravity to speak. The sky does not often grant such courtship. More commonly, the visitor sweeps past at dozens of kilometers per second, lifts tides too small to measure, and fades blueward into day. Solar tides trace lines of stress inside the nucleus, but do not write new orbits. The Roche limit, where a body would be pulled apart by differential gravity, lies far closer than the safe approach any observer welcomes. A small, cohesive object with a spin not too wild will sail through unchanged. Jets might flare under stress, seams might creak, a fan might sharpen and then soften again, but the arc of motion does not notice. The curve is set by mass and distance. Surface drama is embroidery. Deflection does carry consequences that are not dynamical in that narrow sense. The bend controls which instruments can see, which hemispheres of a rotating nucleus feel noon and night, which vents wake earlier under a changing sun angle, and how long high-cadence monitoring can track individual features in the coma. But none of these practicalities touch the central fact. The invitation is thin, because the well is deep only near the fire, and the time spent near the fire is short when the entrant arrives already swift. Some will ask about exotic means. Could the coma act as a parachute against the solar wind? The solar wind is sparse. A square meter at Earth's distance feels a pressure of a few nanopascals. Even multiplied by the area of a small mountain, the deceleration is microscopic. Could charged dust interact with the magnetic field in a way that drags the nucleus? Charges ride fields well, but the nucleus is neutral and massive. Its path is inertial. Could a collision with a small asteroid arrest the motion? The volume swept during the weeks of crossing is vast and mostly empty. Two stones meeting at such speed would shatter into a spray that still carries the original surplus. There is one more graceful perspective. Escape velocity at Earth's orbit is about 42 kilometers per second. Add the inherited speed in quadrature, and a number appears that tells how fast perihelion will rush by. For a visitor bringing 20 kilometers per second from infinity, perihelion will see nearly 46. For one bringing 30, the sum grows to over 50. Those velocities are the signatures of motion that cannot be held. They are a measure of how briefly the instruments will drink, and how quickly the figure on the sky will pivot and depart. The solar system is a country with borders defined by energy, not by fences. A traveller can enter the airspace, circle the capital, and cross back through the perimeter without stamping a passport. Sometimes a patrol officer in the form of a giant planet asks a pointed question. If the answer is yes to a rare geometry, the traveller stays and becomes a resident with a new name. If the answer is no, the encounter remains an episode. Light fades, numbers harden into orbital elements, and the stranger continues east of the sun, carrying the same gentle refusal it brought from the west. The invitation is real. It brightens the sky for a season and opens a moment when instruments gather truth at high speed. It is also limited by clean laws that do not waver for romance. Momentum replies with courtesy. Thank you for the curve. No, I cannot remain. The trace left behind is not a captured body, but a deepened understanding of how space welcomes without keeping, and how a star can be both a hearth and a gate. Time arranges the encounter with a clarity that borders on austere. A line from far away is bent by the sun, touches a single bright noon, then returns to distance. The curve is symmetric in form while the meaning is not. Each hour closes behind the traveller like a door whose hinges never swing the other way. The passage is a one-way crossing set to a tempo that cannot be slowed by desire. It is arrival written inside departure, not by metaphor but by mechanics. Clocks on Earth count the days to closest approach. Schedules thicken with exposure blocks, calibration frames, and handoffs between longitudes. None of this changes the fact that every observation spends the future. A minute at the detector trades for a minute less of opportunity. The object moves tens of kilometers in each second near perihelion. During a single long exposure, it advances a distance large enough to smear a point into a faint streak if a telescope tracks the stars instead of the target. The correction is simple in principle. Track the moving point. The cost is paid in sky background, and in the patience required to rebuild faint signals from many short frames before the moment is gone. Light needs its own travel time. Photons leaving the coma at dawn reach a mirror minutes later, sometimes tens of minutes when geometry stretches the path. Each image is a memory rather than an immediate report. To place observations in order, one must subtract the light time and rewrite the ledger in the object's clock. The correction is not romantic. It is arithmetic. Yet the result folds a small philosophical twist into the work. Even at a distance measured in fractions of an astronomical unit, knowledge about the visitor is already the past. The orbit itself is a clock that runs on angle. True anomaly replaces calendar entries. Inbound and outbound are the same curve mirrored about the sun, each point a twin to a point yet to be reached or already passed. No choice offered on the ground can disturb that pairing. The object will sweep the outbound longitudes at nearly the same speeds it used on the way in, modified only by small forces from its own breath. Perihelion is not a station. It is a hinge that never closes again on the same house. Entropy adds its signature to the arrow. Sunlight pours down a gradient, is absorbed by a crust darkened by ages, and re-emerges as heat a little lower in temperature and a little more spread out across space. Gas finds a path from order to disorder in seconds. Water breaks into fragments under ultraviolet. Daughters run outward in expanding shells, and their kinetic stories thin into silence. Dust escapes, collides seldom, and carries warmth into a tail that curls under radiation pressure. The energy flow cannot be reversed, and the mass shed will not be gathered back. A kilogram lost to the wind is gone for good. Time for the nucleus is therefore not just geometry. It is erosion measured in grams per second while the clock of motion counts down the days left to shine. The coma speaks in durations. Lifetimes for CN at 1 astronomical unit run to hours. OH glows for longer, then fades. Ions trace the solar wind for distances that can be crossed in minutes by a proton travelling at hundreds of kilometers per second. Dust persists. Micron grains sail for days before drifting far enough to vanish into the sky's brightness. Millimeter grains linger near the nucleus for hours, then ease outward as gas dwindles. The tail is a time series written as a spatial gradient. Near the head is now, farther back is yesterday, farther still is a week ago. In a single frame, the past is visible as distance. Precession or tumbling motions fold yet another period into the scene. A vent that faces the sun at local morning one day may see dusk at the same rotation phase a week later. The changing orientation modulates thrust vectors and coma features on a schedule that only begrudgingly stabilizes. A period search uncovers a cluster of candidate hours rather than a single clean value. Observers learn to work with windows. They aim to catch the same phase under similar viewing geometry before geometry itself migrates away. The opportunity to lock onto a repeating pattern narrows with every Earth turn. Parallax writes a daily kink into the track. As the planet spins, the line of sight sways east and west. For a target only dozens of lunar distances away, the sway is measurable over a single night. Ephemerides correct for this with precision that borders on poetry. A world turning under a sky that seems fixed must learn to subtract its own motion, to follow a traveller that is in a different dance. The correction is a reminder that time at the detector is braided with the planet's rotation. An hour lost to cloud cannot be repaid tomorrow with the same geometry, the same phase angle, the same alignment of tail and streamers. Thermal inertia delays and compresses the daily cycle. Gas flow typically peaks after local noon and drifts into evening. When the subsolar latitude migrates during the few weeks of closest attention, the daily breath slides across longitudes on the nucleus. A fan that sharpened in one night's dusk may shift to next night's afternoon, and then fade. Features do not simply repeat because the sun climbs to the same height in a given sky. The height is measured on a surface that is rolling and wobbling through a once-in-a-lifetime season. The math of prediction narrows as time advances. Early in the campaign, sky positions come with error ellipses measured in arcseconds. Each recovery shrinks the ellipse. Near peak brightness, the uncertainty falls below the width of a seeing disk. After the turn outbound, exposures grow longer to keep pace with fading. The ellipse expands, not because the orbit is unknown, but because the signal is being chased into background noise. Time enforces clarity, then immediately enforces ignorance, not capriciously, but with the regularity of changing flux. Instrumental strategy becomes a choreography of scarcity. When the moon swells, narrowband filters salvage the nights by rejecting continuum glare. When the object dips to low altitudes at dusk, higher air mass imposes extinction and smear. Teams adjust by stacking shorter exposures and by leaning into blue lines less affected by atmospheric absorption. When atmospheric water vapor thickens, infrared plans are shelved and radio moves to center stage. These are not inconveniences. They are the texture of a visit that refuses to wait for perfect conditions. The clock does not pause when the weather is unkind. Relativity makes a cameo. At speeds of tens of kilometers per second, time dilation is so slight that no instrument will ever record it directly. The factor differs from unity by a few parts in a billion. Over a month, that amounts to milliseconds. In the balance of practical astronomy, that delay is dust. Yet at the level of principle, it joins the chorus that says motion modifies the way time is experienced by clocks that ride with the traveller. The fact that such an effect is present and ignorable at once becomes a small parable about scale. A different dilation matters more to the senses. The apparent rate on the sky accelerates near closest approach, then decelerates. Features in the coma that were easy to track from frame to frame, one night become blurs the next, then settle again as the geometry opens. The eye perceives urgency, then reprieve, then absence. The curve is smooth. Perception is not. It hears accelerando, a bright crescendo, and a falling away that resembles silence. Every discipline meeting at the telescope speaks in hours. Photometry wants cadence to resolve rotation. Spectroscopy wants dwell time to build signal in faint bands. Polarimetry demands long series at varied phase angles. Radio wants a dark, dry window to chase a ladder of lines across the dawn. None can have everything, so each asks for slices of a finite calendar. The compromise is not a loss. It is an ensemble piece. The target generates a suite of clocks. The planet supplies old clocks of night and weather. The community learns to weave them without resentment because the visitor will not circle back. Time-stamped data become a bridge that outlives the moment. A night sequence saved in a public archive can be remeasured years later with better reduction methods. The photons do not fade after they have been written into counts and calibrated. What fades is the possibility of repeating the exposure under those exact conditions. The arrow is strict in reality, gentle in memory. Knowledge continues to accrue from the same raw material long after the object has vanished into a part of the sky where no instrument can still follow it. There is beauty in the strictness. A story that knows its ending cannot be padded. The encounter allows only a finite number of chances and then retires. That finitude focuses attention. It sharpens decisions about what to measure now, what to surrender, what to leave for instruments better suited to another angle next week. It also leaves a humane residue. Those who looked carry a sense that every object passing through the inner system writes an hourglass into the air, and that listening means learning to speak in grains that fall only once. Patterns seduce the mind with the promise of order. Instruments gather light on strict cadences, hoping for a steady rhythm to emerge from the noise. Instead, the data breathe like restless weather. The brightness swells and ebbs by a few tenths of a magnitude on hours-long scales, then stutters with minute long twitches that no simple rotation can explain. Fourier power spreads into a broad hill instead of a single peak. Autocorrelation rises, fades, and never locks in. Wavelet transforms show islands of quasi-periodicity that live for a handful of cycles, drift in period, and dissolve as if embarrassed to be seen. The traveller performs variations without theme. Jets are the first suspects. A vent warmed by morning can cough awake, sharpen into a sunward fan, then sag before noon if the feeding crack lifts pressure and chokes on its own frost. Thermal inertia stretches and offsets the daily breath. A fissure on a slope may meet dawn early and dusk late, while a neighbouring pit lies in shadow until a higher Sunday. Each feature follows its own timetable. The nucleus turns, but the vents do not simply obey the hour, they obey place. When the line of sight projects two active regions onto the same few pixels, their lights overlap like notes that refuse harmony, beating in and out of phase and writing a jitter that drifts. The spin state adds another layer of mischief. A rigid body with a single axis would stamp a clean period onto the light curve once the coma contribution is modelled away. Instead, the signature wanders. Non-principal rotation allows the long axis to precess, while the body also spins about that axis. The angles that matter for sunlight and for jet thrust change slowly and unevenly. The same vent sees different noons from night to night. Simulated light curves built from such motion reproduce a telltale behavior seen in the data. Peaks shift by tens of minutes over a week, then snap back when geometry turns a corner, then vanish behind a brighter cycle that steals attention. Gas and dust collaborate to confuse. If coarse grains dominate, the coma's contribution to brightness becomes sluggish, responding to vent changes with a delay set by the time heavy particles need to drift into the photometric aperture. Fine grains act faster and add their own flicker. A small burst can lift a swarm of submicron particles that forward scatter sunlight with disproportionate flare when phase angle is high. On such nights, the measured flux leaps suddenly, then relaxes as dust dilutes. Color and polarization follow suit. A neutral tone reddens for an hour as larger grains take the stage, then swings bluer when fragile clumps fracture in flight and flood the inner coma with fresh, tiny shards. Polarization minima shift by a degree or two, then creep back. Nothing in these shifts is wild, yet the ensemble refuses to sit still long enough for a neat periodic rule. Solar wind weather writes its own graffiti across the scene. Ion tails kink, disconnect, and regrow in response to changes in the interplanetary magnetic field. A disconnection event can strip ions downstream and briefly clean the plasma environment near the nucleus. Charge exchange rates wobble, electron temperatures jump. The neutral coma then brightens or dims in certain bands without any corresponding change in the nucleus. Photometric apertures, unluckily aligned with the ion tail, may catch glints from freshly formed ions that masquerade as nucleus-driven activity. Instruments record a tremor. The engine, in that moment, is the wind, not the vent. Fluorescence adds a small clock all its own. Molecular bands do not shine with constant efficiency. As radial velocity changes, solar absorption lines slide across molecular resonances and modulate band strengths in a subtle pattern called the swings effect. The modulation is small but real. When it aligns by chance with changes in projection geometry, band flux can hiccup by a few % against a steady abundance. Analysts correct for this, yet the correction carries its own uncertainties. Residuals remain, perched right where a tidy rotation signal would otherwise sit. Geometry is inconstant across a fast visit. Phase angle grows, peaks, and recedes over days. The observer's vantage point slides in latitude relative to the nucleus, exposing and hiding fans whose planes are not perpendicular to the line of sight. A corkscrew jet that read cleanly one night can rotate into a face on spiral the next, lowering contrast and smudging its photometric imprint. Syndine and synchrone maps that fit a tail on Monday need retuning on Thursday as the projected radiation pressure vector tilts. The dust physics is faithful. The view is the shifting culprit. Inside the coma, grains collide seldom, but not never. Coherent clumps released from a single throat can shear and shatter as gas speeds differ across their faces. When a fragile aggregate breaks, its subunits present more surface area to sunlight, increasing brightness without any new mass leaving the nucleus. Fragmentation cascades are intermittent, keyed to subtle thresholds in rotation, illumination, and local gas density. They write pops into the light curve that lasts minutes. Wavelet power spikes, then falls quiet. A model that emits fragmentation must invent spurious jets to explain the same features. Electrostatic lofting plays at the margins. Near the terminator, the electric field can levitate the smallest grains before gas claims them. A faint, narrow halo appears, almost stationary in the nucleus frame, then is swept away when a jet surges. The effect is both delicate and local. It modifies the brightness profile within a few tens of kilometers and casts tiny shadows into the polarization map. On nights of immaculate seeing, such traces can be measured, though they waver at the edge of reliability. Even if accepted, they contribute jitter without duty cycle. Observers test the sturdiness of their own methods. Differential photometry against dense fields removes most atmospheric wandering. Point spread function fitting corrects for seeing variations. Apertures are scaled to the seeing disk to keep a constant fraction of core light. Photometric standards calibrate 0 points. After these disciplines, some noise evaporates. What remains is structured. The Allen variance of the residuals refuses white noise and leans toward flicker. The Hurst exponent sits above a half, implying persistence. Brightness increments remember recent history. The signal is not random, it is merely not repetitive. Analysts try to impose sense without cheating. Period searches are performed with Lomskargel and with phase dispersion minimization. Candidate periods are kept only if they survive when the series is decimated, when the photometric aperture is altered, and when color channels are separated. Cross-correlation between bands reveals delays of minutes consistent with dust and gas responding on different clocks. The best-fitting rotation is not one number but a narrow band that drifts with time, as if precession were nudging the clock face while the hands moved. Quasi-periodic oscillations appear with quality factors too low to honor with the word period. Models catch up by admitting switches. Markov state models let jets toggle between on and off, with probabilities tied to solar elevation and to prior state. Monte Carlo dust codes inject grains with size distributions that change in short spurts rather than smoothly. Radiation transfer is allowed to see aggregates whose scattering matrix evolves as they break. The simulated light curve begins to look like the sky. Peaks are similar but never identical. Valleys repeat in families, not as clones. Polarization wobbles by a few percent in step with color, but the phase of the wobble wanders, as observed. The psychology of search is not immune to this landscape. Minds built to find tides in chaos must teach themselves to accept pattern without permanence. Confidence intervals take the place of claims. Words like likely and consistent replace words like proved. Far from being a retreat, this posture earns more truth from the data. It prevents the temptation to force a clean rotation onto a body that refuses to be a metronome. It privileges the lived physics of vents, fractures, and flight over the tidy comfort of a single repeating hour. The result is a new idea of order. The system is lawful but not clockwork. It is a web of coupled processes that share energy and timescales only approximately. Heat diffuses a few centimeters into crust. Pressure climbs in cracks and falls through valves that have no hinges. Grains launch, shatter, and drift according to rules that depend on dimensions measured in microns and in kilometers. Solar wind rattles the plasma just enough to braid ion light across dust light. The sum is a pattern that keeps changing its mask. The watchers adjust their practice accordingly. Rather than chase a single period, they map families of behavior. They archive power spectra through time, not one spectrum for the whole encounter. They schedule polarimetry to sample a grid of phase angles, not to ride a presumed rotation. They treat spikes as physics, not nuisance. They learn to expect a live object, not a mechanism. The sky rewards that humility with coherence that arrives in pieces. A vent repeats a gesture after 3 days, not 2. A color shift returns when geometry aligns again, not because an internal clock ticked. Jitter becomes narrative rather than failure. The portrait that emerges is truer for its restlessness. The traveler is not trying to hide. It is trying to be what it is. A small, irregular repository of ice and dust, stirred by heat, pushed by light, nudged by its own breath, and accompanied by a halo whose grains carry their own variable temperaments. Patterns exist. They simply refuse to sit still long enough to be mistaken for destiny. Earth has been speaking for a long time. Sparks across telegraph wires, voices folded into radio, music inhaled by the ionosphere and exhaled to the stars, radar pulses thrown like pebbles across planetary faces, narrow beams from great dishes stitched into the night with mathematical patience. The sum of these efforts is a faint, swollen shell, a whispering sphere growing outward at the speed of light. Inside it, nations talk to themselves. At its edge, syllables thin to noise and then to almost nothing, yet still they move. The planet is a lighthouse. Whether or not anyone stands on a distant cliff to see, the question lingers in that glow. Could a lighthouse call a voyager from interstellar dark? Physics offers an early answer with the quiet firmness of arithmetic. The power that leaves Earth in all directions is large by human standards and microscopic by celestial ones. Radiation pressure from those emissions is so small that dust near the antennas cannot feel it, much less a nucleus hundreds of millions of kilometers away. The energy carried outward does have mass in the strict accounting of relativity, but the gravitational influence of that mass is weaker than a thought. As a physical tug, our transmissions are less than a feather in a gale. The object did not turn because it was pushed by our songs. Informational summoning tempts a different imagination. If someone listened, could they have replied with a messenger disguised as a comet, a careful device wrapped in ice and dust? The geometry of time sets difficult constraints. The oldest wide broadcasts have reached a radius measured in a modest count of light years. A reply that rides on a physical object must travel slower than light. If a neighbor at the edge of that sphere heard a century ago and launched immediately, the messenger arriving now would need to outrun physics by an unseemly margin. A closer neighbor could, in principle, dispatch a swift probe. The coincidence of hearing, deciding, launching, and arriving at this particular moment would then have to be layered precisely over Earth's rising capacity to see faint visitors. The chain is not impossible in the way that square circles are impossible. It is only so tightly engineered that the simplest reading prefers coincidence and readiness to intention and reply. There is a humbler and more human meaning of summoning. A species learns to watch with better eyes. It builds surveys that do not tire, workflows that do not blink, networks that turn a faint moving fleck into a shared target before breakfast. As those disciplines mature, the rate of discovery rises. Objects that would have slid by unnoticed begin to accumulate in memory. From within that change, it feels as if attention has called new things into being. In fact, attention has only lowered the threshold at which the already present becomes visible. The arrival is not the stone. The arrival is the moment when the stone and the watcher finally intersect. Selection effects are patient tricksters. If instruments are most sensitive to visitors that pass within certain distances, those are the ones that will fill the record. If data pipelines are tuned to subtract yesterday from today with a particular tolerance for motion on the sky, certain speeds will percolate through more often than others. A community then looks at the list and reads features that are partly carved by nature and partly carved by its own habits. From such a list, the mind can assemble a story of calling and answer. It is not a false story, but it is incomplete unless it includes the caller's ears and methods as characters. Apophenia is another tied to respect. Brains are built to pull constellations from static and faces from clouds. They relish agency, because agency was a survival skill long before it was a philosophy. When a rare visitor appears during an era of global listening, a line invites itself between the two. The seduction is understandable. It turns randomness into relation and relation into meaning. But meaning that leans only on coincidence can be a bridge that spans no river. To test it, one must ask, what would have happened if the visitor had arrived a decade earlier or a decade later, or under a sky fractionally less crowded with instruments? In most such counterfactuals, the stone still passes. The difference lies in who notices. There remains the whisper from quantum law that observation changes outcomes. It does, in laboratories where particles are coerced into choices and whispers are amplified by careful apparatus. On scales of ice and kilometers, that tenderness is averaged away. Photons that lift chemistry from a coma do not care who will measure the bands. Grains that scatter polarized light do not lean toward one phase angle out of shyness. The only observer effect at work is social and cognitive. Observation changes the observers. It collapses doubt into shared numbers. It turns a traveler into a chapter in a long book. That transformation is not trivial. It is the making of knowledge. But it does not bend orbits. The possibility of a participatory cosmos, in which measures select histories, is a thought experiment with philosophical flair. It is also a poor tool for steering stones. Retrocause remains a word better suited to paradoxes than to comets. If a future detection could pull a past path into being, the universe would be a hall of mirrors with no stable furniture. The sky behaves with more sobriety. It grants coincidence, rhythm, resonance, and tide. It withholds teleology. There is still a way that the world might be said to summon without violating any principle. Imagine a shore and a sea. The shore builds a pier that reaches farther out. The sea does not aim waves at the pier. Waves simply come. The pier meets more of them and measures more of them and weaves a tighter rhythm from their impacts. The pier grows again, adds lights, adds sensors, and soon the pattern seems fuller. The sea has not changed. The shore has shaped its own ability to hear. The resulting music is a joint creation, but the causation runs from readiness to recognition, not from desire to arrival. Another layer of context belongs to the galaxy itself. The star and its planets drift through regions where interstellar dust and rocks are unevenly sown. Streams peel from young clusters. Tidal tails thread the dark with slow trains of debris. Over long times, flux can rise and fall as the system passes through richer and poorer neighborhoods. If a tide lifts the number of wanderers for a few millennia, the rising curve will overlay the century in which a technical species happens to raise its gaze. Correlation will then tempt the word summoning. The agent is not the species. The agent is the orbit of a star through the ecology of a spiral arm. Metrics can be honest and kind at once. The pressure of Earth's broadcasts on a nucleus is negligible. The light from the sun is the pressure that matters. The gravity of Earth's field is an influence only during a very close pass. The gravity of the sun writes the curve. The most powerful human-made beam, even if aimed perfectly by accident, cannot play the role a planet plays in a gravitational exchange. These truths do not shrink human effort. They right-size it. They remind that attention does not move mountains. It maps them. There is also grace in admitting how attention moves minds. The act of asking whether signals called a caller reveals a deep hunger to be in conversation with the cosmos. That hunger has consequences within culture. It funds machines. It recruits apprentices. It spreads a habit of patience. In that way, the question is performative. It builds the very scaffolding needed to catch the next visitor earlier, to measure it better, and to separate coincidence from pattern with more confidence. If summoning means preparing a room so that a guest will not be missed, then yes, the planet has been summoning for generations. The last echo returns to the lighthouse image. A beam turns, touches a ship, and slides on. The ship did not steer because of the light, but a sailor on the bridge glanced up, confirmed a course, and passed a message to the helm. Knowledge changed something small and human. The sea and the sky continued large and indifferent. Between those scales the story unfolds. A visitor crosses the field of view, instruments register, minds assemble significance. The growth of that significance is the only summoned thing, and it is enough, because meaning is the harbour where encounters come to rest. 3 stories compete to explain arrival. Accident offers a shrug, elegant in its simplicity. Target imagines intention behind geometry. Tide proposes a wider clock, a slow metronome set by the galaxy itself. Each story lays out evidence in the language of angles and speeds. Each invites a verdict from the same set of photons. Accident begins with statistics. Space is not empty of small bodies cast off by forming systems. Planets grow by scattering. Icy rubble is ejected when giants rearrange. Fragments wander between stars for millions of years. The sun is a moving collector with a finite cross-section. Given enough time and enough seeds, something will graze the inner system. The encounter rate should be a Poisson rain, sparse but impartial. Detection then applies its own filter. Surveys favour the night side of Earth near opposition, prefer slow apparent motions that remain point-like during short exposures, and return to the same fields often enough to subtract yesterday from today. Those habits cut a jagged window in a smooth flux. Inside that window, a passerby becomes a discovery. Outside, it remains a ghost. Accident therefore looks like intention. Whenever readiness happens to coincide with approach, geometry adds a second layer to accident. Gravitational focusing by the sun bends far tracks inward and fattens the target presented by the inner system. A visitor that would have missed by a safe margin in a Newtonian straight line is persuaded into a closer pass. The bending raises brightness and shortens the time to peak. Two gifts to telescopes that prefer confidence. Focusing does not aim the object at any particular world. It merely tilts the odds toward wider visibility. When discovery follows, it feels like a rendezvous. Accident shrugs again and points at the cross-section. Selection bias strengthens the illusion of choreography. Surveys rooted in the ecliptic naturally discover more objects that arrive near that plane. Programs that watch the morning sky collect a different family than programs that haunt the midnight meridian. Weather tilts the sample, moon phase sculpts it. Even software preferences matter. Pipelines tuned to reject high sky rates will reject swift interlopers more often than slow ones. After a year of such habits, a dataset acquires a personality that belongs partly to nature and partly to the watchers. Accident wears the watcher's fingerprints without malice. Target tells a more dramatic tale. In its strictest form, it implies a sender who noticed Earth's rising voice and dispatched a messenger disguised in dust. That story must solve timing. Radio leakage has reached a modest sphere around the Sunday. Any listener at its skin who decided to respond would need to launch a craft that flies slower than light but arrives barely a century later. And by chance, during the decade when surveys became acute enough to see faint, fast intruders, the chain can be imagined. It strains the prior. A milder target hypothesis replaces agency with natural guidance. Could the object have been steered by hidden resonances to a geometry that sends it near Earth? Not by radiation pressure on a solid nucleus, not by the solar wind on a neutral rock, not by magnetic fields that hold ions but ignore mass. Without a thick medium to bite, steering is wishful language. There is a subtler use for the word target that does not require a plot. The inner system itself is a lens. Near the sun, the velocity vectors that enter a narrow cone of approach are deflected by similar angles. If Earth happens to be there, encounters cluster in a short season. Repeat that alignment every year with different wanderers random in phase and phase space, and a human calendar will appear to host hot weeks. This is not pilots aiming for a runway. It is optics. The lens selects. Telescopes applaud. Tide offers its case with patience. The galaxy has a field that tugs on distant reservoirs of ice around stars. That background pull shakes comets loose from wide Oort-like clouds and feeds interstellar space with a slow drizzle. Passing stars lay additional hands on those reservoirs. Some pass so near that their gravity stirs a local storm. Streams of debris peel away from young clusters and keep their shared motion for millions of years. Spiral arms, and the central bar herd orbits into resonant patterns that alter encounter rates. The sun, drifting along its path, steps through patches of richer and poorer rubble. Flux to the inner system rises and falls on timescales too long for news cycles, but real enough to matter. If tide is at work, approach directions may whisper a pattern, not a narrow beam, but a gentle preference for arrival from the neighbourhood of the solar apex or its opposite, or a tendency to cluster along great circles connected to known associations. To test this, one stacks approach radiance in a galactic frame and looks for overdensities. A handful of interstellar arrivals will not settle the question. A dozen might begin to speak. Tidal origin also predicts a distribution of speeds anchored to the local standard of rest more than to any planet. Excess velocities should look more like the spread of nearby stars than like a selected corridor aimed at Earth. Stellar encounters draw clear predictions as well. A recent glancing passage of a red dwarf could have stirred a particular stream of debris that trails behind it. If that is the case, inbound vectors for interstellar visitors may align roughly with the path of that star. The correlation would not be exact. Rocks scatter, but an echo should persist. If no such alignment exists across multiple visitors, the tide may be more diffuse, a background effect of the galactic disk rather than the wake of a single neighbor. Orbital alignments provide tests for every story. Accident anticipates no preferred longitude of ascending node, no special argument of perihelion, only the broad bias that surveys impose. Target, in the strong sense, might favor exact encounters with Earth's orbit and times keyed to terrestrial seasons, signatures far sharper than any natural lensing could produce. Tide expects coherence in galactic coordinates rather than in ecliptic ones, and velocities that make sense when measured against the motion of nearby stellar streams. Each new arrival can be plotted in these spaces. Each plot is a vote. Jupiter stands at the edge of these arguments as an indifferent judge. If interlopers frequently slide near its hill sphere, gravity assists will spray them through a family of exit vectors that could mimic aim. In practice, high interstellar speeds leave Jupiter too little time to act. The number of tracks that thread its keyholes is small. Those that do will show clear dynamical scars in the outbound direction. A pattern of Jupiter-styled bends across many arrivals would support the notion of a natural guidance that concentrates encounters by mechanics alone. A lack of such scars strengthens the case for a broader background tide coupled with accident. Bayesian thinking brings the three stories into one room. Before looking at any data, the prior that an object was dispatched intentionally is very small. The prior for a random interstellar visitor is larger. The prior for modulation by galactic structure sits between them. Evidence updates these priors. A single inbound speed consistent with local stellar dispersion moves the needle toward tide and accident together. Repeated alignments with Earth's calendar would pry the needle toward target. The absence of both would keep the balance on accident, shaped by known lenses and biases. There is also a practical test only time can administer. If a stream exists, objects drawn from it will arrive with related velocities and directions for years. Their light curves and chemistries may even rhyme if they share a nursery. Once enough are tallied, a cold river will be visible in phase space. If the tally instead remains scattered, the verdict leans toward impartial drizzle. Instruments will continue to watch, and the sky will be allowed to keep its counsel until statistics become a voice. The most generous synthesis keeps the three tales in proportion. Accident governs the meeting at the level of one stone and one star. Target, in the literal sense of an engineered delivery, waits for evidence it has not yet earned. Tide shapes the long baseline, raising and lowering the population of wanderers that accident can select from. Within that scaffold, human readiness plays a role that looks like summoning but is better named listening. A planet improved its ears. The sea of space did not change for that improvement. What changed was the count of waves that became music. What remains for instruments is clear. Plot every radiant in a galactic frame. Track speeds against the local standard of rest. Note any repeated longitudes of node that survive bias corrections. Search for families. Report emptiness honestly. Over years, those maps will decide custody of cores with more grace than any argument waged on a single encounter. If a tide is lifting, the map will darken along a band. If a target exists, the map will bloom with an impossible arrow. If accident reigns, the map will resemble wind-blown dust. There is humility in that image. Dust dances under currents it cannot predict and arrives where it was blown because there was room to pass. A visitor does the same. The mind presses for intention and receives instead a curve shaped by gravity, a brightness tuned by chemistry, and a rate set by galactic weather. Accident, target, tide. The simplest holds strongest until a pattern insists otherwise. Meanwhile, the instruments keep counting, and counting is the oldest way to tell the truth. Word count, 1167, awaiting un. Bạn đã nói, chassis. Do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not linked source. Thiên văn 22 section đã nói. đã suy nghĩ trong 20. Section 14. There is a quiet idea that walks beside the measurements. What if engineering can wear a comet's mask? The suggestion enters gently because it knows how easily desire paints faces on clouds. Yet it lingers long enough to ask for tests. If artifice hides in ice and dust, what would its light do that nature's light does not? If purpose glides beneath a veil, how might that purpose leave fingerprints that rise above chance? Kinematics is the first place to look. Natural outgassing produces tiny thrusts that strengthen as sunlight grows and fade as it wanes, often with delays set by thermal inertia and by the rotation of vents into day. Radiation pressure, in contrast, pushes on area, not on heat or chemistry. A thin structure with a large area to mass ratio would feel that push in a way that mimics a constant sunline acceleration when seen over short stretches of time. If one fits the motion and finds a persistent nudge that scales as light itself, and not as a volatile's timetable, suspicion earns a note. If the nudge rotates when the object rotates, as a sail might, the note grows louder. None of this proves intention, but it sketches a silhouette of something broad and light rather than small and dense. Photometry can ask about sheen. Ice and dust scatter in ways that are rich but soft, with glows that vary smoothly as geometry changes. Certain materials used by engineers can make highlights that are abrupt. A specular flash, brief and wavelength consistent, marching with a repeating phase as the body turns, would argue for facets with exceptional smoothness. Natural crystals can flash, but their timing usually blurs under coma, haze, and texture. An inventory of short, sharp glints, repeating with clock-like patience, would be a different language. Polarization offers a complementary lens. Fluffy aggregates of grains tend to produce a specific curve of polarization versus phase angle, with a shallow negative branch at small angles and a steady climb. Metallic or dielectric films can flatten that curve or move its landmarks. A surface that polarizes very little across a wide range of angles may be either a metal sheet or a field of very large compact grains. A set of angle-dependent measurements across colors can separate those options. If the result points toward a mirror, then engineering returns to the conversation. Thermal behavior holds more clues. Icy dirt responds slowly to daybreak. It warms from the skin inward. Temperature maps would show strong day-night contrast and lag. A structure with high thermal conductivity and low heat capacity behaves differently. It warms quickly, equalizes across its surface, and cools without much delay. In mid-infrared colors, this looks like a smaller amplitude of diurnal variation than dust and ice would exhibit. Emissivity features can help as well. Minerals wear fingerprints. Polymers and films carry others. If the spectrum slides away from lithic and icy bands toward an unfamiliar smoothness, caution becomes curiosity. Composition leaves the longest trail. Natural comae carry recognizable molecules and their daughters. Ratios vary, but the menu is familiar. An engineered shell that sublimates for camouflage would still reveal human-style chemistry, only if its coating were exotic. Metals shed ions, not Cn or C2. Polymers might crack into chains that fall outside the usual bands. If careful, high-signal spectra in the visible, infrared, and radio bands fail to find expected families while still finding dust, one must ask what feeds the dust. A coma rich in solids and poor in gas is not rare, but when gas lines fall below credible limits across many windows, the absence itself becomes a datum. Radar, when geometry allows, can be decisive. Cometary nuclei are dark and radar-shy. Their echoes are soft and broad. A high radar albedo and a narrow echo would suggest hard, smooth patches. Metal will talk loudly to a transmitter. The practical obstacle is distance and speed. Most interstellar passers race too far and too fast for radar to reach. Still, even a failed attempt constrains possibilities. If no echo returns when an echo should, the case goes the other way. Radio listening brings its own discipline. Engineering speaks most efficiently with narrow band tones, drifting slowly with relative motion. Nature broadcasts widely, with bands shaped by molecules and by plasmas. A search across centimetre and metre wavelengths for carriers that hold still within Doppler expectations can be made alongside optical work. A tone that locks to a rotation phase or to perihelion would open a door few could close. The default outcome is silence. That silence is not proof of nature, only a reminder that absence is common, even when questions are brave. Morphology of the coma tells stories about control versus weather. Vents carving steady, sunward fans and corkscrews that track rotation suggest internal plumbing and sunlight as the metronome. A coma with edges too sharp, with edges that hold their shape against changing phase angle as if actively shaped, would be unusual. Dust size distributions are another test. Nature loves power laws. Monodisperse grains are rare, without sieving. If in situ polarimetry and color mapping argue for a narrow grain size that stays narrow for days, especially if aligned with a possible attitude, then the notion of planned shedding earns attention. Dynamics can expose intention in small ways. A tiny course change that appears after a long quiet, not correlated with increased activity or with geometry, might be a jet or it might be a burn. One distinguishes by collateral evidence. A jet leaves chemistry and dust. A burn that vents nothing leaves only motion. Precision astrometry tied to spectra can keep those threads separate. If motion shifts while gas lines remain asleep, the story changes tone. Isotopes provide a deep check. Natural reservoirs give water with a particular deuterium fraction, carbon with a balance between 12 and 13, nitrogen with its own split. Long journeys in irradiation can nudge those ratios, but only within ranges. If measurements land in numbers far from any known region's habits, a puzzle is born. An artificial origin could in principle choose ratios, though there is no reason to do so unless compelled by materials available in a foreign workshop. In practice, this test demands more signal than most fast visits allow. It remains a hope, not a promise. Every one of these signatures has a natural twin. Specular flashes can be ice plates turned just right. Flattened polarization can come from coarse, compact grains. Low gas alongside bright dust can be the gift of a sealed crust that vents through cracks. Tiny accelerations along the sunline can be jets too smooth to catch in our lines, or an unevenly lit shape that pushes itself with vapor invisible at our sensitivity. The task is to build a mosaic where the natural twins fail together. No single oddity should carry the case. A cluster must point one way. Philosophy watches from the balcony. Extraordinary claims should rest on beams of evidence thick enough to hold weight. At the same time, a reluctance to ask the question can blind. The soft way to proceed is to write testable predictions and treat them with fairness. If a sail, then non-gravitational acceleration should map to sunlight with a constant area to mass ratio over weeks. If a shell, then mid-infrared phase curves should be flatter than dust models allow. If a transmitter, then tones should repeat with rotation and align with pointing that changes as torque changes. Each prediction either lives or fails in the data. There is a final form of the hypothesis that is less about messengers and more about archaeology. Imagine the corpse of a machine that has wandered for ages, stripped of coverings, seeded with frost in shadows, pitted by dust. What remains could mimic a rock. Its cavities would collect volatiles and release them in sunlight. Its panels would not reflect like new metal, but they might still confuse a polarization curve or a glint map. If the universe builds civilizations, their wreckage might be as common as their voices are rare. The sky could hand us relics dressed as stones. Until numbers force a change, nature owns the presumption. Ice, dust, heat, and light explain nearly everything with generous grace. The artifact idea stays soft-spoken, present as a reminder to keep certain doors unlocked. The way to honor it is not with slogans but with discipline. Listen for tones while measuring bands. Fit radiation pressure while modeling jets. Seek glints without turning every flash into a mirror. Build cases that would convince a skeptic who wanted to say no, then look for the one sign that refuses to be natural, no matter how the model leans. If that sign ever appears, it will not diminish the sky made by physics. It will enlarge it by adding intention to the list of forces that matter in certain corners. Until then, the beauty lies in how far patient measurements can carry inquiry without leaning on hope. A traveller wrapped in light tells its story. The story is chemistry, geometry, and motion. The possibility of craft is a footnote that waits for a sentence strong enough to hold it. Word count 1180, awaiting un. Bạn đã nói, Shiwu, do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not linked source. Thiên văn 22 section đã nói, đã suy nghĩ trong 17. Section 15. There are coasts in space where ice keeps different promises. In some nurseries, sunlight is gentler and red. In others, it is sharp with ultraviolet. In one place, carbon hides easily in gas. In another, it freezes into stone bright breath. Chemistry does not forget the shoreline where it learned to speak. When a small body carries its childhood across the dark, the rules it obeys in the new light are shaped by that first weather. Every protoplanetary disk lays out snow lines like contour lines on a map. Closest to the star, water cannot hold a solid form. Farther out, the water snowline appears and grains acquire frost. Beyond that, carbon dioxide condenses. Farther still, carbon monoxide settles out, then nitrogen at the very coldest edge. These distances are not fixed to a single number. They slide with stellar luminosity, with the density and turbulence of gas, with the rate at which pebbles drift inward and evaporate. A pebble can cross a snow line, shed one volatile, and keep others, picking up new material as it drifts toward warmth or outward again on a pressure bump. Layers form, each written at a different temperature and pressure, each holding gases in different cages. Amorphous water ice can trap foreign molecules inside its matrix. When that matrix reorganizes into a crystalline lattice as it warms, it exhales what it hid. Clathrate hydrates provide a second warehouse, a structure where water cages lock gases into place at specific pressures and temperatures. The release from these cages is not the same as the simple evaporation of a pure volatile. It happens in steps. A history that includes trapping will show activity that rises early in the cold from carbon monoxide or nitrogen, then rises again when water crosses a threshold where its lattice changes and opens its store. A different history, one with little trapping, will keep to a smoother law. The color of the parent star matters. Around a small red star, the disk is cooler and the snow lines lie close in. The spectrum is rich in red and infrared, modest in ultraviolet except for flares. Ice forming there sees long periods of gentle photons and sudden bursts of harsh ones. Organics can build slowly on grain surfaces, then crisp in an instant during a flare. The proximity of the snow lines allows pebbles to cycle repeatedly between warm and cold as they drift, leading to fractionation where some species are bled away and others are enriched. A body born in that region carries ices that remember both calm and outburst, a recipe that favours resilient crusts and trapped gases that hesitate to vent. Around a hotter, bluer star, the snow lines stand far from the centre. Ultraviolet light is not a visitor, but a climate. Carbon dioxide forms readily under such light, and water can be photolysed into radicals that stitch complex organics. Gas disperses faster under radiation pressure and winds. Grains that grow there may incorporate more processed material at birth. Comets assembled in that field can begin life with skins already darkened and pores already half closed by chemistry that wrote varnish while the disk still gleamed. Their cores may keep abundant supervolatiles that condensed at great distances, but their faces could resist steady flow and vent only through thin arteries. Disks do not share the same carbon to oxygen budget. If carbon is plentiful relative to oxygen, water becomes scarce. Carbon binds into refractory compounds and into long chains, and the leftover oxygen is not enough to drape every grain in ice. Such a nursery crafts bodies whose comae will later show dust rich in carbon and volatiles skewed away from water. Colors tilt toward red, polarization curves shift with grain compactness and coating, and the familiar dominance of water lines in a warm coma gives way to a palette where carbon monoxide and methane speak more loudly when geometry permits. A different balance, one with oxygen more abundant, writes the reverse. Water becomes the carrier, and carbon hides in the skin as organics rather than as gas. Temperature at birth leaves isotopic fingerprints. Deuterium enriches water at 10 Kelvin in dense clouds, where fractionation favors heavy hydrogen. Nitrogen tells its story in the split between two isotopes when it freezes at very low temperatures. If a small body formed at the very edge of a wide disk, or in a cold pocket where external illumination was screened by dust, those ratios will be shifted. Journeying through interstellar space will roughen the numbers but not erase them. Later, when measured in the breath, the ratios place the object on a contour line that few local comets share. Pressure and turbulence pick the textures of grains. Where the disk is thick and stirred, collisions are frequent, and aggregates grow in chaotic ways, branching into airy clusters. Where the disk is thin and calm, compaction can follow growth, aided by frost that sinters contact points. The result is a change in scattering habits. Airy clusters brighten forward scattering and deepen particular polarization features. Compact grains mute both. A nucleus assembled from grains that learned under one regime will carry that optical memory into a coma that looks slightly foreign under our Sunday. Giant planets carve highways through young systems. When one migrates, it drags resonances across the disk and ejects bodies into wide, barely bound orbits. Later encounters kick some of those bodies into interstellar space. The ones ejected early can leave with cores set by the cold periphery and skins set by the sourceless radiation far from any star. The ones scattered late may have tasted brief summers at smaller distances before being thrown away. That difference matters when sunlight returns. A veteran of cycles near a star will open its valves more readily. A refugee that never warmed will meet its first real day when it crosses our orbit and will answer it warily. There is also the faint possibility of birth in a region rich in carbon monoxide and nitrogen, where water was second in line. Such bodies would seem odd in our sky. They would activate at large distances, breathing carbon monoxide into space, with little water to ride along. Near the sun, they might still hold back because their crusts formed in cold that built thick armor. If those crusts contain clathrates, the release of gases can arrive stepwise at temperatures that do not match the pure species curves, a rhythm that confuses simple activity laws. Shorelines include magnetic weather. Young stars hurl winds that thread their disks with fields. Charged particles sculpt chemistry by breaking bonds and generating radicals that recombine. The top micrometers of every grain turn into a dark film where carbon networks absorb light and resist heat flow. A body born under such winds will inherit a skin that behaves differently from skins cooked by ultraviolet alone. When warmed later, that skin can impede gas diffusion and feed dust more readily than vapor, reshaping measured ratios in ways that have little to do with the actual interior inventory. Sunlight is not the same everywhere, even when it supplies the same power per square meter. A red star loads the spectrum toward longer wavelengths that sink a little deeper before they reflect or are absorbed. A blue star front-loads energy into ultraviolet that the very first layers of a surface will intercept. The thermal profile down into the crust will differ. The depth from which gas can escape will differ. The meaning of local noon will differ. A visitor that learned its thermal grammar under one sun will keep that grammar in its reflexes when it comes to another. Some bodies may even have formed where shock waves from nearby supernovae or massive star winds compressed the disk and heated pockets abruptly. In those pockets, crystalline water could grow even far from the center. Crystalline ice packs molecules poorly compared to amorphous ice. It traps fewer guests. A nucleus built from such ice would release supervolatiles only in proportion to what was condensed as pure phases, not as passengers. Its coma would whisper fewer daughters from trapped parents and show dust that mirrors a history of sudden annealing rather than gentle glaciation. All of these shorelines leave testable hints. Ratios of water to carbon monoxide and carbon dioxide map, where the body kept its cold. The presence or absence of nitrogen traces deep freeze or clathrate abundance. Ortho to para ratios in water or ammonia fix a thermometer at assembly. Polarization curves sketch the architecture of grains. Color slopes and forward scattering tell about coatings and compaction. Activity that steps rather than flows suggests traps and transitions. Each hint can be framed as an origin card, and compared with models of disks around different stars, the picture that gathers is not a single portrait. It is a gallery of coastal scenes, where frost takes different shapes, where light has other flavors, where winds write different scripts into the first centimeters of rock and ice. A traveler that seems mildly strange under our sun may be entirely ordinary under a different spectrum. It carries a shoreline in its chemistry and in its grains. When sunlight touches that shoreline again, the rules it follows are those it learned long ago, and the strangeness is simply the dialect of another home. Word count 1165, awaiting un, Bandanoi, Shalot. Do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before-after section. Do not linked source. Tien Van Hai Hai section Danoi. Section 16. Distance is a slow sculptor. A small body set adrift between stars spends ages under a weather that has no clouds, only particles and light. Cosmic rays arrive with energies that ridicule chemistry and pass through meters of ice before easing. Ultraviolet from distant suns trickles in, not bright, but unceasing. Tiny grains of interstellar dust collide at hypersonic speed, each impact a whisper of erosion. The sum across millions of years is a rind that did not exist at birth, a skin that changes how heat moves, how gas escapes, how light is scattered, and how motion betrays itself to instruments. That skin can resemble intention. It can throw narrow jets, flatten color curves, tame outgassing into thrusts that seem measured and sun-aligned. It is craft without a craftsman, the handiwork of time. High-energy particles start the masonry. Protons and heavier ions lance into ice and organics and leave tracks of broken bonds. Radicals recombine into long carbon networks that darken and harden the topmost layers. At depths measured in millimeters, ultraviolet does most of the work, stitching thin films that act like varnish. Deeper by centimeters and tens of centimeters, cosmic rays dominate, rearranging ice into a denser, more chemically complex mixture, and forging refractory residues as lighter molecules are slowly surrendered to space. The porosity near the surface changes. Pores that once linked to the vacuum become blind alleys. Diffusion paths lengthen. The thermal conductivity shifts. Sometimes it grows as glassy bridges form between grains. Sometimes it falls as voids close off and layered organics hoard heat. Micrometeoroids hammer this evolving crust. A speck hitting at tens of kilometers per second behaves like a tiny explosive. It melts and splashes a smear of glacified debris that quenches into a crusty glaze. Repetition builds a mosaic of welded patches, brittle but cohesive. Every crater adds a rim. Every rim adds a shadow that can preserve pockets of colder material under a sun that is never present but always implied. Over many blows, a lag deposit forms, rich in dust, poor in easy vapor. The topmost grains become locked together by sintering at contacts and by the very resins produced by radiation. This shell is not thick by planetary standards. Depths of centimeters can suffice to change behavior. Yet the effect on breath and brightness is dramatic. Interstellar cold keeps ice in its amorphous phase. Amorphous water has room for guests. It traps carbon monoxide, nitrogen, methane, and other small molecules within its disorder. When heat finally arrives, the amorphous lattice rearranges into a crystal and exhales the tenants it caged. That release is spiky and staged. It introduces steps into gas production curves that would otherwise be smooth with distance. The release also begins below the varnished skin, where rising pressure must find a route through a crust that resists. Cracks become valves. They open, hiss, and close as stresses change. Each valve is a primitive nozzle that collimates gas and drags dust into jets with edges sharp enough to look designed. Thermal cycles in deep space are slow, dictated by long rolls rather than quick day-nights. Even so, they raise and lower temperatures by degrees that matter for cohesion. Differential expansion across bonded grains produces stress. Over thousands of cycles, a network of microfractures spreads. Fracture mechanics maintains a ledger no eye can see, tallying when a path will link a trapped pocket to the surface. When it does, pressure falls in a rush. Dust leaves in a coherent sheet that breaks into clumps and then into grains. To a telescope, such a release looks like a controlled puff. It is controlled by history, not by intent. The evolved mantle is an insulator that redirects heat laterally. Sunlight falling on one patch spreads through the crust before reaching ice beneath. Local noon loses its tyranny. The peak output from a vent can slip toward afternoon, or even into evening, and can depend more on the crust's topology than on the angle of the Sunday. This delay turns smooth curves into syncopated rhythms. It also aligns thrust with the solar direction more consistently than a raw, porous surface would. The escaping gas sees the shortest, clearest paths that happen to aim sunward. Over days, the average push leans toward the sunline, with a steadiness that mimics sails and ignores the mess beneath. Color and polarization respond to the mantle's chemistry. Organic films steeped by radiation mute spectral slopes, sometimes reddening, sometimes flattening into a dark neutrality. Fluffy aggregates lofted from below inherit this coating. They scatter with a signature that nudges polarization curves away from local templates. The changes are not exotic. They are subtle shifts in the positions of minima and the heights of peaks. But the pattern is consistent with grains built in one workshop and lacquered in another. When phase angles are favorable, forward scattering surges as large. Ragged aggregates reflect light like small, misaligned mirrors. Highlight flickers appear and disappear, tempting misreadings as specular hints of engineered planes. Sputtering by ions introduces a slow leak from everywhere at once. Molecules are ejected from the surface, not by heat, but by momentum transferred during collisions with energized particles. The rate is tiny per square meter, but enormous in aggregate over centuries and across the whole body. Sputtering replaces the topmost monolayers repeatedly, exposing fresh material to radiation and then altering it again. It also frees atoms that would never have escaped through diffusion. Those atoms rebond nearby or depart into space. The balance between rebonding and escape helps set the thickness of the veneers that struggle against inward heat. An old traveller can carry a patchwork of skins with different ages and different resistances, and that patchwork will write a tapestry into the coma when the star rises. Interstellar winds contribute a personality to motion long before any star is approached. Charge exchange between neutral gas around the body and ions in the medium can form an invisible sheath. The sheath is far too tenuous to push a nucleus. It is not a sail. Yet it can precondition the outer layers of gas released at great distance by very cold, supervolatile sublimation. Ionization fractions near the body creep upward. When the sun appears and photography begins, the ion tail already knows how to orient. It swings into place quickly and can confuse early attempts to tie changes in plasma light to changes at the surface. The net of all these processes pushes dust to the fore and hides gas under thresholds. If most pores are sealed, gas flows through few cracks. Dust liberated at rims and flakes by thermal and mechanical stresses can dominate the coma even when gas production is modest. Photometry reads a bright fog. Spectroscopy finds lines that whisper. The ratio resembles deliberate disguises or conserved fuel. It is neither. It is the natural consequence of a varnished rind that resists and a scaffolding beneath that yields solids more easily than vapour. Geometry receives the mantle's imprint as well. Pits formed by sublimation from below act as bowls that collimate. When cracks vent into those bowls, the flow emerges in tight fans that stay tight as the nucleus rotates. Adjoining bowls will not be synchronized unless similar layers reach similar thresholds at similar times. The eye, trained by launch videos and engineered plumes, sees control in the neatness. The cause is simpler. Cavities act like nozzles in the way a canyon makes wind sing. Nature uses shape to focus breath. On the scale of entire trajectories, non-gravitational acceleration acquires a disciplined look because the mantle averages chaos. Many small, intermittent thrusts over a rotation cancel in lateral directions and add in the direction that spends the least energy fighting the crust's resistances. Sunlight sets that direction. The signature that orbit fits recover is a gentle, nearly constant push aligned with the sun more often than not. Its value drifts with heliocentric distance as temperature changes open or close reservoirs at depth. The scene resembles a planned sail. The plan is a field of microstructures obeying mechanical rules. Heat flow models reproduce this character when the mantle is included. A one-dimensional conduction equation with depth-dependent conductivity and permeability, a source term for crystallization release, and a sink for sublimation can deliver activity curves that shift phase, flatten near perihelion, and spike when thresholds are crossed. Add cracks as stochastic valves, and the light curve acquires flicker. Change the mantle thickness or chemistry in the model, and polarization and color respond in ways that match real changes measured by telescopes. The skin is the control knob. Turn it with a finger named time, and the response is the same as if someone had meant it. As distance grows again, the mantle survives the season of light. Only a thin fraction of its mass is lost. The crust cools, and rehardened films repair their fractures at the molecular level. The new scars become part of the next performance when another star is passed, or when the same star is met by chance centuries later. In that sense, the weathering is cumulative. Each bright encounter edits the surface. Each long night between stars edits it more slowly. The two editors write in different hands, but on the same page, and the new script always approaches a similar style. Darker skin, narrower vents, stronger cohesion, slower gas, bolder dust. The paradox of this weather is that it hides and reveals at once. It hides the interior's abundance behind a resisting face. It reveals itself openly by producing signatures that instruments can trace back to universal processes. Decorative coincidences with technology are precisely that, coincidences born of convergent functions. A nozzle focuses flow, whether carved by a mission architect or by stress lines around a pit. A sail responds to light whether it was unfolded by a crew or assembled by radiation into a lace whose mass is small for its area. The difference lies in intention, which leaves additional signs that physics alone cannot counterfeit for long. What remains, after the crust's lessons are accounted for, is a traveller that wears an honest mask. The mask was built by particles, by rays, by silence, and by time. It thickened slowly, cracked when pressurized, welded under tiny fires, and learned to ration its breath. It turned a once porous skin into an instrument that modulates heat and motion with surprising grace. The illusions that follow are ours, reflections of tools and metaphors we know well. The reality is simpler and no less beautiful. Long journeys teach endurance. Endurance shapes a face. That face looks purposeful only because purpose and patience arrive at similar forms when they are asked to survive a long, cold road. Word count 1190. Awaiting un. Badanoi. Should see. Do not use. D. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not linked source. Thiên văn 22 section đã nói. Đã suy nghĩ trong 13. Section 17. Listening begins with a map of wavelengths. Each band is a different ear, tuned to a different grammar of light. Optical cameras catch the sunshine scattered by dust and the fluorescent shimmer of simple molecules. Infrared spectrographs taste the warmth of grains and the breath of carbon dioxide that ground air often hides. Ultraviolet instruments follow daughters of water as they glow after sunlight tears them apart. Millimeter receivers listen for the quiet rotational whispers of carbon monoxide, hydrogen cyanide, methanol, and their kin. Radio dishes lean into the 18-centimeter line of hydroxyl that mazes politely when geometry smiles. Even soft X-rays can appear, born from charge exchange where fast solar wind ions steal electrons from neutral gas and leave a ghostly aurora around a traveler with no magnet. Eyes on Earth coordinate with eyes in orbit. Ground telescopes crave dark, dry nights to lower the sky's own brightness. Space instruments offer windows where the atmosphere is opaque and time is rationed like air on a climb. Schedules are written against ephemerides that carry uncertainties at first and improve with every new position measured. Non-sidereal tracking allows mirrors to follow the target's motion rather than the stars. Exposure times shrink to keep a point from trailing into a wound. Stacks rebuild depth later, aligned in the moving frame so that the object grows while the constellations smear. In these practical moves, there is a rhythm that feels like music for machines. In the optical, two styles of listening share the night. Broadband photometry tracks total light and its color. Narrowband filters carve out the bright lanes, where CN, C2, C3, NH, and OH rise above dust. Calibrations use solar analog stars to divide out the star's spectrum and leave a reflectance curve, a way to see whether grains are redder or bluer than sunlight would make them. Imaging polarimeters split light into orientations and recombine it into a map of polarization, degree, and angle. Those maps speak of porosity and shape. A sudden kink in polarization along a jet gives away the sizes of grains just freed from a crack. Infrared work is an art of windows. Near the ground there are bands where water vapor steps aside and lets emission pass. In those lanes, the blackbody curve of warm dust becomes measurable, a thumbprint for grain temperature and emissivity. Farther into the infrared, space is obligatory. There, carbon dioxide sings with strength that the sky would otherwise swallow. Methane and ethane pick their own places to speak. High-resolution spectrographs separate lines very near one another, allowing isotopes to reveal themselves by tiny shifts. Retrieval codes climb through these forests of lines and return production rates and temperatures with confidence bands that admit complexity rather than pretend certainty. Millimeter arrays turn gas into geometry. Rotational lines of simple molecules appear at well-known frequencies. Their brightness traces column density. Their widths and shapes reveal expansion speeds in the inner coma. Ratios between lines in the same species measure excitation, temperature. Maps at a few arc-seconds resolution transform a cloud into a flow, revealing offset sources that act like vents, and gradients that point from morning to afternoon in the nucleus frame. Where the signal allows, hyperfine structure in hydrogen, cyanide, and other molecules tells whether lines are thick or thin, turning guesses about abundance into firm accounts. Ultraviolet sensing follows the daughters of water with patience. The broad features of hydroxyl are difficult from the ground and straightforward from orbit. Once measured, they invert back to a water production rate, corrected for solar activity that modifies lifetimes. Ultraviolet also shows the oxygen lines that act as sentinels for carbon dioxide when the infrared is out of reach. The ratios between the green and red lines change subtly depending on which parents feed the oxygen. That change is a cipher that spectroscopists have learned to solve with care. X-rays are rare and instructive. They emerge when fast ions from the sun meet neutral gas and capture electrons into excited states. The resulting cascade makes soft X-rays that wrap the coma in a faint aura. Imaging them paints the border where solar wind turns, and the comet's flow asserts itself. On nights when the wind is agitated, the X-ray light flickers. That flicker is a monitor of space weather written on the face of a visitor. Occultation campaigns bring a different kind of listening. If the path of the traveler crosses in front of a star bright enough to track precisely, small telescopes spread across a continent can watch the star and record the exact moments it dims. The coma dims gently. A hard dip within the soft dip can betray the nucleus itself. One successful chord yields a size limit. Several chords trace a silhouette. Timing to fractions of a second means kilometers on the sky. The event lasts a breath, and then becomes a line in a log that will outlive the night. Occasionally, geometry allows radar. A transmitter sweeps a coded signal across the object and waits for the echo. Delay gives distance. Doppler spread gives rotation rate. Echo strength hints at surface roughness and composition. Cometary nuclei are usually shy, returning weak, broad reflections. A bright, narrow echo would suggest facets that nature seldom builds at this scale. Most often, the echo is silence, which is itself a datum. The images that ordinary cameras deliver are not ordinary to the hands that shape them. Contrast enhancement filters, like rotational unsharp masks and Larsen-Sechenina transforms, pull faint jets and spirals from the glare. Synchrones and syndines are drawn across the tail to separate time of release from grain size, allowing the trail to be read as a diary laid down with every hour of sunlight. When a corkscrew jet writes a helix into the coma, its pitch and handedness betray a rotation and a pole direction that spectroscopy alone would leave vague. Precision matters at the level of catalogue and pixel. Astrometry ties position to reference stars whose coordinates are known exquisitely well. The choices of catalogue and distortion model decide whether a measured push is genuine or an artifact. Photometry swears fidelity to standards whose magnitudes anchor the night. When seeing blurs, the core point spread function fitting replaces simple apertures. Apertures grow with seeing in some pipelines so that a constant fraction of the inner coma is always measured. Each of these rituals reduces noise by admitting it exists. Coordination across longitudes turns a single planet into a composite eye. When dawn closes one dome, dusk opens another. Networks of moderate telescopes keep cadence, while large mirrors pursue scarce photons in faint bands. Amateur observatories contribute high-cadence morphology under clear skies that professionals cannot always command. Their images, when calibrated and archived, extend the time base to a continuity that would be impossible otherwise. In a dossier written against a clock, continuity is power. Data storage is a kind of memory that resists distance. Images and spectra enter public archives in formats that carry their histories with them. Calibration frames, skyflats, and darks accompany the science frames like passports. Years later, when algorithms for faint structures have improved, the same pixels can be coaxed to yield detail that was invisible on the first pass. A world that the light has left remains present as numbers that can be reread. Models meet this river of data with humility. Vectorial models turn parents into daughters through lifetimes and velocities that depend on distance and wind. Monte Carlo dust codes release grains in sizes drawn from distributions that can change with time and with latitude on the nucleus. Radiative transfer respects the way aggregates scatter and absorb. MCMC samplers walk through parameter spaces that are wide and correlated, returning families of solutions rather than a point. The goal is not to force a simple story. The goal is to find what many lines of evidence can carry together without complaint. At the edge, new techniques wait. Interferometers stretch baselines to resolve the inner coma at scales where jets are born. Integral field spectrographs record a spectrum at every position across a small field, making cubes that connect chemistry to shape. Spectropolarimetry overlays polarization on spectral lines, separating dust light from gas with precision. Machine learning helps pipelines find subtle features without mistaking noise for novelty. None of these replace patience. They amplify it. The dossier that emerges is not a single photograph. It is a quilt of bands and times, of flashes and quiet curves, of maps of polarization stitched to ladders of lines of orbits refined by echoes and by star dips, of tails converted into release calendars and comae converted into thermometers. Many eyes write it, many hands reconcile it. In the end, it reads like a biography told in several languages at once. The subject does not speak, and yet everything it is becomes legible when light is given enough ways to land and enough minds to translate. Word count: 1166, awaiting un. Badanoi, Shubar. Do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before-after section. Do not link source. Thiên văn 22 section .noi. Section 18. Equations gather like birds on a wire. Coordinates are chosen, frames are changed, and a path that is only minutes old in the ledger is asked to confess millions of years of history. The first step is simple on paper. Position and velocity are lifted from the solar system's center to the system's barycenter, then carried outward into a galactocentric frame that treats the Sun as a moving province within a larger state. A 6-number state vector becomes a seed. Around that seed, a storm of clones is grown, each nudged within the uncertainties of astrometry and within the small blur that non-gravitational thrusts have already added. The goal is not one line backward through time, but a spray that shows how ignorance blooms. Gravity writes the software's grammar. Symplectic integrators are favoured because they conserve the music of Hamiltonian motion over long marches. Time steps adapt to keep close passages honest and distant drifts efficient. When outgassing matters near the Sun, a high-order method takes the wheel for a while, then hands it back once the jets fall silent. The model of the galaxy is layered. A thin disk pulls in the plane. A thick disk adds weight farther out. A central bulge tugs softly, and a dark halo sets the deep curvature where stars circle unseen mass. The Sun itself oscillates above and below the galactic midplane, rising and falling on a period measured in tens of millions of years, while it slides along a slightly eccentric path around the center. Each clone is marched backward. Close planets are kept in the calculation till distance turns their influence into round-off. After that, only the solar system's total mass matters. Then even that fades, and the clones become tiny ships in a wider sea. Uncertainties fatten the path quickly. The tube of probability that points inbound from the present swells into a river. Lyapunov times are short when small forces are included, and even with perfect gravity, the unknowns in the earliest images decide where the river spreads. What reads as a line on a plot is in truth a fog in 6 dimensions that grows until it no longer resembles anything like a single route. Behind the integration sits a quiet translation engine. Velocities measured in the heliocentric frame must be compared to the local standard of rest, the average motion of neighbours on the same galactic road. The object's peculiar velocity is the leftover after that subtraction. If the leftover is small, ejection from a nearby system needs only a modest push, and the travel time can be long without contradicting anything. If the leftover is large, something brisk must have happened when the body was expelled, or the traveller has been stirred by encounters that heated its orbit in the statistical sense used by dynamicists. Origin searches begin in catalogues of stars with full-phase space measurements. Positions, proper motions, radial velocities, and estimates of gravity and age define where those stars were, and how old their disks might have been when they could throw debris away. Each star is propagated backward in the same galactic potential that carries the clones. Where a star's track intersects the widening spray, a candidate encounter appears. The relative speed at that moment, the closest approach distance, and the age of the star at the inferred time are compared to what planet scattering and cluster tides can plausibly produce. A soft ranking grows. Most candidates fall away because the required geometry is too sharp, or because the speed is implausibly high. A few linger as maybe. Ejection physics adds priors to this game. Young planetary systems scatter ice and rock with a range of speeds set by the masses and alignments of their giants, by whether a passing star disturbed or did not, by whether a binary companion stirred resonances or never existed. Speeds of a few kilometers per second are common. Tens of kilometers per second are not impossible, but they are rare without violent help. Those priors feed a Bayesian frame that weighs each intersection between clone and star. A slow, close miss in the right century of a star's youth is attractive. A fast, glancing pass near an old subgiant is not. Clusters complicate and help. Many stars are born in groups that drift apart over time, each member taking a small family of debris with it. If a traveller left such a nursery early, its initial speed was set in a frame that moved with the cluster. Later, as the cluster unwound, the traveller, the sun, and the former siblings spread along related lanes. The way to test this idea is to drive clones through a census of dissolved groups reconstructed from their surviving members. If several clones pass through a corridor where a ghost of a cluster can be traced, the probability rises that the traveller is a child of that field. If no such overlap appears, the blank is not a failure. It may simply mean the nursery was too poor to leave a detectable trail, or too distant for present data to resolve. Chaos is a teacher here, not a villain. Even if a particular star never emerges as the source, the statistics of all close passages say something solid. They sketch the density of potential birth systems as a function of age, show whether the likely travel time is millions or hundreds of millions of years, and reveal if the typical relative speed it encounters resembles the low values of gentle ejection or the higher values one expects from slingshots near compact binaries. That sketch informs every physical model built from the coma. If the time of flight is likely long, the skin should be old. If the speed is modest in the local standard of rest, then the chemistry may speak more of a quiet nursery than of a violent childhood. Error growth becomes a character with moods. Uncertainties in the non-gravitational parameters act like small torques applied in ignorance. Going forward, they are minor. Going backward, they make clones diverge faster than the purely gravitational case would predict. This does not mean the exercise fails. It means the answer is a distribution, not a point. Visualizations respect that by painting probability density in galactic coordinates, and by tabulating encounter likelihoods rather than single star names. If a name survives such skepticism, it is a gift. If not, the unnamed cloud is still a result. There are practical thresholds that shape what can be known. Radial velocities for many nearby stars are measured well. For others, they are uncertain by a kilometre per second or more, and that gap becomes 40 parsecs of positional blur over 40 million years. Ages are harder still. A star may wear lines that whisper youth or middle age, but the calendars they imply have broad margins. If chemistry suggests a very cold birth, a young red dwarf in the candidate list feels right, but today's data will not convict or acquit. The map must wait for better numbers while keeping the present truth tidy and honest. Some teams go farther and simulate ejection from model planetary systems forward in time until forwards meets backwards. Architectures with one migrating giant produce one distribution of launch speeds and times. Architectures with multiple giants in quiet resonance produce another. Binaries throw yet another. For each architecture, a cloud of test particles is kicked out and released into the same galactic potential. The subset that wanders through the solar neighborhood with positions and velocities like the object in hand is counted. Counts turn into likelihoods. Likelihoods turn into a statement as modest as it is valuable. This kind of nursery is favored. That kind is not. There is a lyrical symmetry in all this number work. On the sky, a single moving dot becomes a tail and a coma that tell of heat and chemistry. In the dynamical archive, a state vector becomes a river of maybes that tells of noise and gravity. One portrait is drawn with photons, the other with numerics, and both are faithful to the same traveller. Neither grants a birthplace you can label on a chart with confidence blue ink. Both narrow a world of possibilities until the remaining map is small enough to talk about without blushing. The most honest ending to a traceback is often a probabilistic postcard. It shows a swath of the sky in galactic coordinates where the clones were most likely a few million years ago. It lists a handful of stars whose paths passed near the swath at the right time, with brief notes on age and speed. It adds a travel time with fat error bars and a relative velocity with thin ones. It admits the fog and treats it as part of the truth rather than as a flaw. From such a postcard, chemistry, photometry, and morphology can borrow context. They do not need a street address. They need a climate in which their clues make sense. Equations do not grieve when they fail to name. They are content to carve away what cannot be, leaving a shape that is useful precisely because it is incomplete. In that shape lies a story about how a small body may have left a cold shore, wandered the disk while the sun hummed its slow orbit, crossed lanes with the wind of spiral structure, and arrived with a speed that belongs to the neighbourhood rather than to drama. The birthplace stays lost behind the widening spray of uncertainty, but the path grows legible enough to honour with a sentence. A traveller came from a common sea, not from a single marked spring, and the sea itself is the address that matters. Word count 1174, awaiting un. Bạn đã nói, Shijou, do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not link source. Thiên văn 22 section đã nói. Đã suy nghĩ trong 13. Section 19. Designers unfurl plots that look like constellations drawn on graph paper. The problem is simple to say and hard to solve. A small stranger slips inward at tens of kilometers per second. Its path is known late. Its visit is brief, and the distance for useful science is measured in a single close brush. What would contact have cost? The architects begin with windows and with fuel. Launch on Discovery is the first sketch. A booster waits with a compact probe sealed above a kick stage. An alert arrives with coordinates and an inbound speed. Trajectory solvers gulp the numbers and return a list of burns that can bend a pursuit into a crossing. Chemical propulsion carries the day because time is short. A solid upper stage supplies a last shove. The geometry strives to turn a near miss into a flyby with a closest approach inside 1,000 kilometers. Every day of delay lengthens the path and hardens the fuel budget. The design earns its name by being ready to leave at once. Preposition patience becomes the second sketch. A small craft loiters in deep night near the sun, Earth balance where station keeping is cheap. It sleeps with instruments cold and clocks warm. When an interstellar track is posted, the sleeper wakes, drops from its post, and shapes its path to the crossing. The saving is delta V that did not need to fight Earth's gravity well. The cost is years of waiting, with batteries that must not forget how to hold charge, and gyros that must not grow stiff. Flyby instruments are chosen by the tyranny of speed. A high-resolution imager rides behind a dust shutter that opens for minutes and closes forever. A thermal infrared mapper sketches temperature while motion smears the field. A narrowband spectrometer collects the fingerprints of water and supervolatiles. A mass spectrometer drinks the coma and tastes parent and daughter species on a clock of seconds. A dust analyzer listens to impacts and weighs grains by the charge and shock they create. A polarimeter maps the glare that tells of grain shapes. A magnetometer sits on a boom and listens to the drape of the solar wind around the gas flow. Each sensor is a sprinter. None will see the target for long. Shielding is a quiet cornerstone. A Whipple stack faces into the flight path like a blunt visor. First a thin bumper shatters incoming grains. Then a gap lets the plume spread. Then a rear wall catches the softened spray. Materials are chosen for fracture, not for strength. Aerogels line shallow pans at the periphery to net a few grains for a return to Earth if the launch and re-entry budget allows. Angled tiles turn, glancing blows into slow slides. The entire craft is oriented during the last hours, so that the shield leads and the telescope peers sideways, like a traveller raising a shoulder against sleet while stealing glances under the brim of a hat. Navigation must start where tracking ends. Far from home, star cameras see fields that alter too quickly for long exposures. Optical navigation takes over. The target is a faint bead against the drift of stars. The craft centers that bead, adjusts attitude, and repeats. The aim is not to hit, but to graze at a range chosen to balance resolution with safety. The final course is carved with tiny thruster strokes that respect the fuel left for safe departure. No one joystick steers in real time. Light time makes that hubris impossible. The craft flies itself using rules written in a language both strict and forgiving. Communication is a gate for truth. The best images and spectra arrive in a burst of minutes near closest approach. Then the target shrinks behind distance while the craft turns to find the Earth, unlock a Ka band beam on a dish that may not be looking yet. The recorder preserves what the link cannot pass. Days of downlink follow. The design includes a low-rate beacon that never stops whispering health through storms and safe modes. The high-rate dump waits while weather and scheduling align. That wait is part of the cost. Because meaning does not exist until bits arrive on the ground, trajectories multiply on the whiteboard. Some rely on a single giant burn into a direct intercept. Others spiral with solar electric propulsion for weeks, trading patience for high specific impulse, then add a chemical sprint to nail the geometry. A daring family performs a solar swing bee, diving inward until heat shields glow, firing an engine near perihelion to harvest the Oberth effect, and flinging outward at a speed chemical fuel alone could not achieve. Those designs demand thermal armor and test ranges few programs can fund on short notice, yet they turn impossible chases into hard but plausible ones. Rendezvous is dreamed and then set aside by arithmetic. To match velocity with a visitor that never slows would require a push of grand scale. Nuclear thermal engines and nuclear electric drives enter the conversation, wearing numbers that sparkle on paper. In practice, the calendar defeats them when discovery comes late. Rendezvous becomes a promise for a future in which alerts arrive earlier and launches are stronger, or for a patient craft that waits in a heliocentric parking orbit with propellant tanks full and engines already tested. Sampling follows a parallel arc. Return of solids is possible without matching speed if capture media are forgiving. Ultra-low-density aerogel can trap dust at swifter impacts than intuition allows, but the angle of incidence must be shallow, and the tile must be sacrificial. A handful of grains could come home. A scoop or harpoon dreams fade. Contact with the nucleus would be a collision at speeds that turn structure into vapor. The team writes a mission rule in terse words: do not aim for the body, aim for the breath. Budgets are written in more than currency. Mass is counted down to grams. Every kilogram saved at launch becomes kilometers per second found at encounter or minutes gained in the inner coma. Power is scheduled into a timeline that has no slack. Batteries carry the peak loads when heaters switch off to give the spectrometers their share. Thermal control pinches and releases the radiators to hold optics at focus. Even the lines of code are budgeted. Autonomy is designed to be decisive and boring. No flourishes allowed that could cost a second when the second will not return. Risk lives in quiet places. A failed separation at launch would strand the interceptor on a dwindling trajectory. A dust storm at the landing site of the downlink dish would cost a night and erase the chance to repeat a spectrum. An attitude glitch near closest approach would rotate the shielded face away from danger and the eye away from truth. Engineers build margins against each failure and accept the ones that cannot be excised. Readiness is the main defense. When time is short, habit replaces heroics. Teams rehearse until a human chain can answer any alarm without speech. A more radical line of thought spends less fuel and more light. A sail, chemical or reflective, would ride radiation pressure to build speed if prepared early and steered with exquisite control. Lasers would push harder, but only if a ground array existed that the world does not yet own. The allure of such systems is that they scale. The sober note is that they scale only after enormous investment. The mission that was almost built must lean on engines the century already trusts. Even the failure case is instructive. A probe launched late, missing the inner crossing by some millions of kilometers, could still measure the ion tail and the dust trail at low risk. Those data would tie plasma weather to chemistry from a vantage few craft have flown. The smaller prize would not justify the same cost, but it would honor the effort by returning something the sky seldom offers. The check at the end of the sketch is paid in 3 currencies. Money buys metal and time under test. Schedule buys probability that a launch can occur before the target is gone. Risk buys speed. The balance suits programs built for vigilance, not for reaction. The way forward looks like a standing capability. A small interceptor, simple and tough, lives on station and listens for alerts. The rest of the plan is a drill that never sleeps. When the next traveler appears, the drumbeat begins without meetings, and a machine glides out to pass within a heartbeat of something the system did not grow. The answer to what contact would have cost is therefore crisp. It would have cost readiness, which is a longer budget than any single object can justify. It would have cost a willingness to pack an entire mission into an hour of data and to accept that the most dangerous minute is the minute closest to the truth. It would have cost a craft built to sprint, to see, and to survive a hail of dust while looking sideways at a world smaller than a mountain and older than any frontier. The price is high. The reward is a portrait only a flyby can paint, drawn at a speed that turns encounter into an instant and an instant into a chapter. Word count 1182, awaiting un. Bạn nói, Archer, do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not link source. Thiên văn 22 section đã nói. Section 20. The word summoning carries a warmth that physics does not promise. It suggests beckoning, intention, a hand extended across distance. Yet there are many kinds of calling. Some move objects, some move minds. The difference matters, because meaning grows from the boundary between force and attention. To ask what counts as summoning is to sort the ways reality answers when a species watches the dark. One meaning is muscular. A lighthouse pulls ships only by gravity and tide. Radio waves slip by with pressure too small to budge a grain of sand. In this sense, no broadcast commands a stone. Summoning by push or pull belongs to fields and masses. If a body crosses the sky, it does so because momentum and gravity have been negotiating for years. A test follows from this. Whenever summoning is invoked, measure the energy budget. If the claimed call could not pay the cost of a change in trajectory, the call is poetry, not propulsion. A second meaning is informational. A listener might hear a signal and decide to answer with a messenger. That is not magic. It is agency riding on awareness. The constraint is time. Light travels quickly. Stones do not. A reply that moves slower than light must be launched early enough to arrive on schedule. The geometry must be fortunate. The craft must survive. This sort of summoning is possible only within tight windows that physics itself narrows. It demands coincidences stacked like plates, each balanced upon the last. The simple rule helps keep perspective. The less leeway a story requires, the more likely it belongs to nature rather than to design. Another meaning is attentional. Eyes sharpen, instruments multiply. Pipelines learn to notice faint motion against scattered starlight. The world did not call a traveller into existence by wanting it. The world taught itself to see. Yet the experience from the inside feels like invocation. Attention changes the count of things that enter memory, and memory is how a species decides what happened. Summoning in this sense is honest. It names the work of readiness. It claims that preparation creates events within culture, not within celestial mechanics. A telescope does not attract a comet. It attracts truth about a comet. There is a narrative meaning as well. Minds crave arcs. A rare visitor arrives during an era of global listening, and a line forms between vigilance and arrival. The story, comforted by that line, binds communities and funds more watchtowers. This is a kind of conjuring, not of bodies but of significance. Significance is not false. It is a currency that pays for future clarity. The risk is projection. When meaning leans too heavily on coincidence, the plot blurs cause with readiness and trades explanation for myth wearing modern clothes. A careful culture can keep these meanings distinct by using tests as gentle guardrails. One is the energy test, already named. Another is the timing test. Could any agent have known soon enough and acted fast enough to shape this encounter? A third is the counterfactual test. If instruments had been slightly worse or schedules slightly thinner, would the object still have passed unaltered? If yes, then observation did not cause the event, it only caught it. A fourth is the agency signature test. Agency leaves patterns that nature struggles to mimic for long. Narrowband tones obeying a clock, coarse changes divorced from outgassing, specular glints that return with machine-like regularity across wavelengths. When those signatures are missing, restraint is wisdom. A final is the conservation test. Explanations should add as little as possible beyond what the data require. When natural processes fit without strain, economy asks that they be preferred. Even with these guards, a softer summoning thrives. It does not violate any conservation law. It treats attention as a tuning fork. Strike the fork often enough, and it sings in sympathy with any wave passing through the room. The tone does not cause the wave, it makes the wave audible. In this sense, surveys, archives, and habits are instruments tuned to cosmic rhythms. They summon audibility. They convert a world of faint possibilities into a handful of concrete measurements. Their calling is a transformation from latent to manifest, which is a genuine power, even if it leaves trajectories untouched. There is a psychological dimension that cannot be ignored. Humans excel at extracting pattern from noise because ancestors survived by doing so. The gift comes with shadows. When randomness arranges itself into a pleasing arrangement, it feels like reply. When two unlikely events coincide, it feels like fate. The antidote is method rather than cynicism. Blind analyses that hide the answer while methods are chosen. Pre-registration of planned tests. Simulations that include the same quirks as the instruments and are subjected to the same searches. In such practices, the itch to call coincidence destiny is quieted, and the residue of significance that survives earns the right to be believed. There is also a civic form of summoning. Stories carry the attention of communities towards shared tasks. A planet may not drag a visitor inward with waves of intent, yet a planet can summon engineers, mathematicians, observers, and students to the same project with a single announced discovery. The resulting network of effort is a force in its own domain. Arrays are expanded, schedules are flexed, new reductions are written, grants are re-aimed. The object remains indifferent, but the world composes itself into an ear large enough to hear subtleties that no single observatory could hear alone. That recomposition is not physics, but it changes what physics can learn. Some will ask if the cosmos itself is participatory, a place where choices affect histories and observation selects outcomes. In laboratories with delicate apparatus, quantum measures do modify what can be said about a particle. Stones and comae are not delicate in that sense. Their behavior is a sum over many micro-events that swallows quantum tenderness and returns classical calm. The only participation available at this scale is the humankind. The shaping of questions, the placing of instruments, the patience to wait for the sky to pass a second time. A useful metaphor comes from cartography. A map does not create mountains. It decides which contours are interesting and which names will be written near the peaks. Once named, a place becomes legible to travelers who might have walked past without noticing. In this way, a community summons a path where none was visible. It opens a route into understanding that becomes more true as more feet tread it. The mountain remains where geology placed it. The map grows, and with it the capacity to return. There is comfort in giving each meaning its own home. Physical summoning belongs to fields and flights, and cannot be done with wishes. Informational summoning is bounded by light, and by the smallness of the sphere that human signals have reached. Attentional summoning is powerful within culture, and honest when not mistaken for cause. Narrative summoning is a tool that must be used with care, else stories crowd out the modest grace of numbers. Civic summoning is real, and it changes how thoroughly a world can answer its own questions. What follows from this sorting is not a loss, but a clearer gratitude. A visitor crosses the inner system because gravity permits it, and because ancient events scattered it. The reason it is known in detail is because a species prepared. Preparedness is the only summoning that never overreaches. It does not claim to pull stones across the void. It proves itself by lowering thresholds, widening windows, and teaching instruments to speak in a shared grammar so that faint voices can be heard. If a day comes when a messenger truly arrives by design, its signature will be permanent and precise. The tone will hold, the geometry will betray its intention, and redundancy will replace wonder with recognition. Until then, there is a different joy. The cosmos is vast enough to send strangers without being asked. Minds are agile enough to catch them. Calling that interplay summoning is not wrong if the word is understood as a name for the choreography between readiness and chance. The beacon that matters shines inward. It lights the rooms where patience lives, trains the eye not to blink, and makes space in thought for an answer that may be nothing more romantic than a clean curve written by gravity, and a handful of bright lines written by breath. Word count 1182. Awaiting un. Badanoi. Archayi. Do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not link source. Thiên văn 22 section đã nói. Đã suy nghĩ trong 12. Section 21. A bright haze around a small traveller can behave like a mirror. Instruments gather the light, and hidden within it is the faint reflection of the minds that built those instruments. Patterns emerge not only from ice and dust, but from attention and desire. In the glare, the world meets itself, and the meeting is easy to mistake for fate. Selection is the first mirror. Telescopes prefer what they can see. They patrol at certain hours, avoid the moon, endure weather, and follow scheduling that gives some longitudes more time than others. Objects that pass near opposition, that move slowly enough to remain point-like during short exposures, that brighten above the floor of a pipeline, are more likely to be discovered than cousins that skim dusk or sprint too fast across crowded fields. The catalogue therefore wears the fingerprint of the search. It looks as if the sky favours a certain geometry, when the truth is that a geometry favoured the searchers. Brightness bends the reflection further. A survey that reaches a given magnitude limit will harvest more large bodies than small ones, more dust-rich objects than gas-proud ones, more visitors with forward-scattering halos than visitors with austere comae. This is not a moral preference. It is an arithmetic one. Measured populations tilt toward what shines. Afterward, if one forgets that tilt, statistics become storytellers that tell of trends that are partly creation and partly curation. Survivorship writes another gloss. Fragile wanderers that would erode violently near a star may never become entries in a ledger, because they shatter at distances too faint for cameras to care. Sturdy ones keep their shape long enough to announce themselves and to be followed. A sample drawn mostly from survivors will overstate cohesion, favour mantles that seal, and undercount the fireworks that weaker bodies would have shown. The echo of endurance masquerades as typical behaviour. Interpretation carries its own leaning. When a new visitor arrives, analysts bring priors trained on families they have studied for decades. Those priors are useful and heavy at once. Bayesian machinery will gladly update, yet the rate of that update depends on widths chosen for initial beliefs. If the first few measurements seem to confirm what is familiar, the posterior tightens too quickly and resists later surprises. If the first few measurements are odd, they can be promoted into myths that later data should have humbled. The mirror is framed by the numbers selected before the first photon was recorded. Publication adds a bright border. Datasets that show peculiarities are written and shared with energy, while quiet confirmations of expectation travel more slowly. The archive fills with interesting features. A reader then infers that oddity is common, because oddity is what the journals exhibit, This is not a conspiracy. It is a habit born of human appetite for novelty. The appetite feeds progress and also warps estimates of how often the sky behaves like a headline. The look elsewhere effect polishes the glass. Thousands of images, dozens of lines, many nights and teams, each carrying multiple tests, will occasionally produce coincidences that taste like patterns. A line brightens exactly when a light curve peaks. A polarization angle rotates on the same night a tail kinks. After the fact, it is easy to circle the match in red. Before the fact, no one would have dared to predict that particular pairing. Without care, the map of coincidences begins to resemble intention. The faithful remedy is to count trials honestly and to withhold triumph when a result is one among many coins tossed. Cognition contributes shadows along the edges. Confirmation bias nudges analysts toward models that vindicate their expectations. The streetlight effect keeps searches under the lamppost of convenience, where tools are strong, while corners of parameter space remain dim. Anchoring holds a first orbit solution too close to its initial values. Hindsight reconstructs the path to discovery as if it were inevitable, erasing the wildness that actually delivered a target to a field at just the right time. None of these shadows are banished by intelligence alone. They recede before procedures, blinding, pre-registering, splitting teams so that one writes the pipeline and the other feeds the data, injecting synthetic sources to test sensitivity, reporting null results with the same dignity as positive ones. An anthropic echo runs quietly beneath the local optics. Observers appear only in conditions that allow observers. That truism can grow teeth if used without care. From it, one can argue that certain coincidences must be as they are, because otherwise no one would be here to notice. In cosmology, this line has work to do. In the intimate practice of chasing a traveller across the inner system, it risks explaining everything and nothing. A kinder use is modest. It reminds that the space of possible encounters is larger than the space that permits detection. What is seen is compatible with seeing, and that simple statement cautions against drawing conclusions as if the unseen were the same as the non-existent. Instrumentation shapes reality at a practical level. Build a pipeline that is skeptical of fast movers, and the catalogue will lack fast movers. Favor red-sensitive detectors, and the population will redden. Open wide filters to drink photons and molecular bands will become levers that are shorter than they could have been. Then, the community will write proposals tuned to that catalogue. The circle closes. Only a deliberate program of complementary instruments, overlapping surveys, and cross-checks can break the loop. Mirrors are harmless when several are arranged at angles that cancel one another's distortions. There is also a social gradient. A discovery that arrives during a season of cultural hunger will be read differently than one that arrives in a quiet year. Symbols attach, metaphors bloom. The science remains itself, but the narration shifts. That narration drives attention, and attention drives measurements, which in turn drive conclusions that appear to verify the narrative. The feedback is not a flaw. It is a force that can be steered if the community admits it exists and sets guardrails to keep story from outrunning signal. Practical corrections are not exotic. Weight measurements by the inverse of survey volume. Simulate populations forward through a model of detection so that inferences are made in the observed space rather than in an imagined perfect one. Report discovery efficiencies alongside every rate. Calibrate with planted sources that mimic real motion and brightness, and are only revealed after reductions are locked. Keep a ledger of non-detections and make it searchable. When unusual patterns appear, query the ledger for how often a similar pattern would rise by chance under the same cadence and weather. Such steps turn mirrors into windows. A thought experiment clarifies what the mirror hides. Imagine repeating the last year 1,000 times with the same instruments and the same sensitivity, only with the arrivals shuffled by a random seed. In how many years would a visitor cross within reach? In how many would it remain unreported because clouds or moon were unkind? In how many would an odd alignment draw attention to a hypothesis that would otherwise have slept? That distribution is the honest background behind every single event. The astonishment of one instance should be measured against the shape of that distribution, not against an intuition that knows only the event it loved. At the core of these reflections is a gentler claim. Meaning does not spring from fate, it grows from constraint. Instruments constrain what can be known. Methods constrain how belief can move. Samples constrain what stories can claim universality. The act of watching becomes an act of self-measurement at the same time. The world counts photons and finds that it has counted its own habits. A traveller's glare is therefore two lights at once. One is the sun, scattered by grains that remember a distant coast. The other is human intent reflected back, showing the outline of the questions that were asked and the tools that were built to ask them. See both, and the scene gains depth. The illusion of destiny dissolves. In its place stands a clearer grace, where surprise is tempered by statistics, where wonder is sharpened by procedures, and where the mirror is not an enemy but a tutor that insists on humility before it allows belief. Word count. 1180, awaiting urn. Bạn đã nói. Do not use. Do not duplicate content. Each part is a new development to help listeners not get bored. Do not reference to before, after section. Do not link source. Thiên văn 22 section đã nói. Đã suy nghĩ trong 11. Section 22. The sky recovers its quiet as the visitor diminishes. Telescopes relax their cadence. Schedulers fold, pages closed. The long arc continues outward, slower to the eye and faster to the heart. A thin bead of light changing into a number, and the number into a memory. The tail loosens until even the most patient stacks find only background. In the darkness that follows, something remains as bright as the object once was. It is the shape of a question that will not go out. Rooms where data sleeps take on a hush that feels like winter after harvest. Raw frames line up in archives, calibrated and cross-labeled. A spectral file opens, and a faint band that once hid beneath noise rises under a different method. A light curve is rebinned, and a shallow rhythm that eluded a first glance steadies into view. The visitor is gone, yet the instrument is still in conversation with it. Every year that brings better algorithms, better flats, and sharper catalogues wakes a small surplus from what has already been seen. The most durable meetings are like this, continuing without the presence of the one who set them in motion. On whiteboards, categories have shifted. The borders around familiar families have been erased and redrawn with wider chalk. A few rules kept, a few softened, a few retired for a footnote that says exceptions live here. In talks, a new word finds a place in headlines and no longer needs to be explained with caution. Students learn to treat interstellar visitors not as legends, but as statistics with error bars. The change is subtle. It is also profound. What once sounded like a story told around a campfire becomes an entry in a textbook that leaves a margin for wonder. In laboratories, a small economy of imagination hums. A spectrograph is tuned for lines that used to be afterthoughts. A polarimeter is given a mode that maps faster. A scheduler learns to trade an hour of deep exposure for a chorus of brief glances when speed on the sky demands agility. Simulators that once ended at the snowline of a familiar system extend their grids into the cold where other suns write different thermometers. Teams that seldom shared notes begin to speak a common language because the traveller asked them to, not with words, but with needs that touched every band and every method. Culture stitches its own responses. A composer writes a slow movement that holds a single note longer than comfort, then lets it go as if letting go could be music. A painter places a small white fleck on an enormous field of dark and calls the canvas a portrait. Children fold paper into tails and watch them arc on classroom air, then ask quiet questions about names and directions and whether meaning can be measured. None of this moves a body through space. All of it moves a body of people closer to steadiness when the next small light appears. The practical residue is a checklist that can be read like a vow. Keep eyes that never blink. Share coordinates before pride has time to veto. Trust small telescopes to keep a beat. when large ones must chase faint colours, carry narrow filters in the drawer, not in distant storage, publish null detections with the same dignity as peaks, archive without shortcuts, treat luck as a guest that visits only those who set a table. There is nothing mystical in this list, yet it has the flavour of ritual, and ritual is how a species remembers what it decided to become. Humility gathers at the edge of the field, content to be unnoticed until needed. It reminds that coincidence is common in large rooms. It whispers that a curve bent by gravity can be hard to tell from one nudged by wishes, and that the way to tell is to count. It suggests that beauty travels well between natural answers and human longings, that one does not have to be sacrificed for the other. It points to empty places on plots and calls them invitations rather than failures. It waits for a voice that will never speak, then finds meaning in the silence that was always the truer language of stone and ice. The long future enters, not as prediction, but as posture. Somewhere, a small object begins to cross the wide valley between stars. Somewhere else, a watch that has not been built yet is already being practiced in the minds of people who are learning their instruments on quieter targets. Technology climbs its ladders in centimeters per year, in software versions and improved coatings, in algorithms that run faster without losing their skepticism. Each rung changes the horizon. Each change alters what can be asked when the brief season of measurement opens. Preparedness is not loud. It is a craft taught by repetition that refuses to be bored. Memory takes on the work of belonging. The visitor does not become ours by staying. It becomes ours by the fact that it altered what we can know and how we choose to know it. A data set shared widely becomes a commons. A method written clearly becomes a path. A result that holds up under reanalysis becomes a stone on that path. None of these are souvenirs. They are tools left in a field for anyone who wishes to harvest when the next crop passes by too quickly for long stories. There is an ethics in this, quiet and exacting. Keep wonder honest. Admit noise without fear. Let beauty be a consequence of clarity rather than a replacement for it. Share first with those who can check you sharply. Teach in a way that invites contradiction and can survive it. Choose language that does not promise more than physics can give, yet refuses to flatten the thrill of a brief meeting with something that learned its habits far away. The ethics is not a rulebook. It is a tone, the sound of careful joy. The object recedes, and the planet stays changed. A curve in an archive is now a hinge around which new questions can swing. A student who saw a faint dot brighten across a week decides not to stop at awe. A builder lays out a plan for a quick mission that might one day catch a breath of dust and return it in a capsule lighter than a person. A teacher writes a problem set where one of the givens is not whether such travellers exist, but what their numbers might be. A piece of sky becomes a place what the mind can visit with coordinates instead of metaphors. Departure is not loss. It is the way knowledge takes a shape that does not need its source in the field to remain alive. The small traveller left without looking back, because looking back is a behaviour that belongs to animals who learned to make meaning. The meaning stayed. It sharpened instruments, gentled language, widened categories, and tuned patience to a higher note. It will wait, embedded in practice, for a season that no calendar can promise, and will be ready whether that season dawns in an ordinary year or in a year when the world needs what the sky can still give. Night closes like a hand cupped over a candle. The flame does not go out. It grows small and steady and learns to breathe on its own. A thin path, once written across the inner dark, now flows outward where eyes cannot follow. In that distance, frost forgets our names, and we remember our work. The domes hum, the screens dim. The last file writes its quiet checksum and joins the others like a seed buried in snow. There is a tide here that no ocean knows. It is the patient pull between a question and an answer that travels toward it without hurry. A traveller brushed our light and moved on. The question stayed behind, bright enough to read by. It says that nothing owned is needed, that a meeting does not require possession, that a story can be complete without a chord resolving to the tonic. It says that what matters first is the clarity of asking. In houses and halls, people close laptops and step into air that smells of leaves or dust or rain. They look up and pretend, for a heartbeat, that they can still see the faint line where a stone once was. They cannot. They see the shape of their own patience. It is a good shape. It has room for early mornings and for mistakes, for laughter at stubborn software, and for the quiet that descends when a spectrum finally shows a line where the plot said there would be one. The sky, large as it always was, tilts slightly toward intimacy, not because it bent, but because the mind learned one more way to stand under it. The word for that is not summoning, it is listening. The ear will be ready again. The dark will still be generous. Somewhere, a small body turns without suspecting it has taught a planet how to wait. The lesson will keep. The light will return, and when it does, a world will recognize the footfall and smile.